Hola. Buenos días a todos.
Hello, good morning everyone. Welcome to the Rice Quality Symposium, US Rice Symposium. For the people that don't know me, my name is Aisha Grisby. I'm the Director of International Promotion at USA Rice, and I'm going to be your moderator today. Today we have the great honor of having very good rice breeder from the US who are going to share the knowledge regarding specialized rice with those characteristics that Latin American consumers prefer. Before we get started, we have some indications so that you have your best experience during this symposium. This symposium will be recorded. There will be simultaneous translation to English, Spanish, and Portuguese. You just have to click on the language that you prefer. The chat is open for your comments, but please use the box of questions and answers so that all your questions or concerns will be answered. In this way, we will be able to facilitate a better conversation. After each speaker, we're going to have a short space to answer your questions, but please don't worry if we are not able to answer your question right then and there. There will be a space at the end so we can answer those questions. Once again, thank you very much for being with us. The next voice that you will hear is from the Chairman and CEO of USA Rice, Mrs. Bessie Ward, who is going to give you some welcome words. She has worked in the rice industry for over a decade. She's a big leader in this organization that pushes the mission and vision of USA Rice. Ladies and gentlemen, our Chairman and CEO, Betsy Ward.
Good morning, everyone, and thank you for joining us for a detailed look at new varieties that both public and private institutions have developed to meet the needs of our customers in Latin America. I'm Betsy Ward. I'm the President and CEO of USA Rice. We are the national trade association for the rice industry and have every segment of the rice industry under our umbrella. We have farmers, millers, merchants, exporters, and end users of rice. So over the last decade, we have heard concerns in Latin America about the quality of our rice, primarily the chalk content. And when your largest export region has concerns, you stop and you listen. We have had extensive dialogue about these concerns with our colleagues and friends from FECAROS in Central America, the Mexican Rice Council, and several major companies to gain a better understanding of their desired rice characteristics, whether it's chalk, amylose levels, grain length, or grain consistency. Our scientists and researchers have been looking at weather patterns, soil health, and planting techniques to see how they affect rice quality, particularly during the fragile flowering stage. And our US breeders looked closely at this agronomic parameters and developed varieties that took into consideration the quality characteristics desired by our customers in Latin America. It takes an average of 7 years for a new variety to be developed and available for commercial production. So we are now finally starting to see some of the most promising varieties that we believe meet your quality criteria. And they're also high yielding, which is very important for our farmers. So today you'll hear from experts in Arkansas, Louisiana, Texas, Mississippi, and California, who will talk about the long grain varieties that their research stations have focused on over the past several years. And you'll also hear from some of our member companies who have devoted significant resources into developing commercial varieties for our farmers to grow that meet your standards. I hope you walk away from this webinar confident that the varieties that are being developed here in the US are profitable options for you and will meet the preferences of your consumers. Thank you so much for taking the time to participate in this important discussion today. We wish we could have done it in person, but we're doing the best we can, as you know. I'll now hand it over to Sarah Moran, who will give you some information about USA Rice and the activities we do in Latin America. Thank you so much.
Thanks, Betsy. As mentioned, USA Rice is the global advocate for all segments of the U.S. rice industry. We represent farmers, millers, merchants, end users of U.S. products, and other allied businesses. We are a one-stop shop for everything having to do with rice, whether it's discussions on sustainability, rice's nutritional profile, or marketing activities, both domestically and abroad. USA Rice is involved every step of the way. All of us here on this webinar know that rice is an excellent food and a staple in most people's pantries. It tastes great, is healthy, and its versatility is amazing. And we want to share that knowledge with consumers worldwide. I, along with 3 other colleagues at USA Rice, oversee our international marketing activities. Since nearly half of the crop we grow in the United States is exported to over 130 countries worldwide, our export markets are extremely important to everyone in the rice industry here. USA Rice is active in more than 24 countries where we invest millions of dollars to promote the sales and consumption of US rice. We work with many partners in these countries, including importers, millers, and packers, so that we can all benefit from these joint activities and the subsequent sales of rice. Activities include in-store demonstrations, media advertisements, social media posts, working with professional chefs or student chefs, and countless other activities. As you may have seen on the slideshow at the beginning of this webinar, we've developed logos to be used during promotions, as well as placed on bags of US rice to help consumers quickly identify the origin. We welcome additional efforts to work with you in each of your markets to increase the sales and consumption of US rice. Here today, we will hear from rice breeding experts from both the public and private sectors who have spent years researching the traits that you, our customers, have prioritized. And they've developed rice varieties that meet these criteria while also being profitable options for our farmers and exporters. Today, you will hear about 25 new varieties that have been developed specifically for the Latin America market. Some of these varieties have just been harvested, and some will be grown commercially for the first time next year. We welcome your comments, feedback, and input so that the rice we grow here helps to grow your businesses. I hope that you find this webinar informative and will reach out to myself, Aisha, or anyone else at USA Rice if you have any questions or comments. Without further ado, I'll hand it over to Dr. Steve Linscomb, who was a rice breeder at Louisiana State University for over 3 decades and currently works as director of the Rice Foundation, which supports research projects to ensure the long-term sustainability and future competitiveness of U.S. rice. Dr. Linscomb will discuss the rice quality parameters that will guide today's webinar. The subsequent 9 speakers will be referencing these terms, so we wanted to make sure they were clearly identified at the beginning. Dr. Linscomb, the floor is yours.
Thank you very much, Sarah, and it's indeed my pleasure to be able to visit with you here today. As Sarah said, I spent many years prior to joining USA Rice as a rice breeder with Louisiana State University near Crowley, Louisiana. During that time, I traveled extensively in Central and South America, and I feel that I've probably met a number of you in those travels. What I'd like to do here today is talk a little bit about some of the quality parameters that our rice breeders are going to be addressing today. So we're kind of all on the same page of what these quality attributes actually mean, the definition of them. I think you're very fortunate today because basically we've got the brain trust of rice breeding in the United States here that will be presenting information, and I feel very fortunate to be a member of that group. So Sarah, next. So when you talk about rice quality, there are certain parameters that are controlled by genetics and others that are mainly due to the environment, and we have a number of them that are influenced by both the genetic makeup of the rice variety and the environmental conditions in which the rice matures. So we have chemical characteristics, we have certainly the shape, the size, the color, and as Betsy said, a big issue that we have been addressing is chalkiness. And chalkiness is one of those characteristics that is very much so controlled both by genetics as well as by the environment. And we'll talk a little bit more about that a little bit later. So next. So acquired properties are certainly ones that the environment has a significant influence on, and the moisture content at harvest can certainly play a role in quality characteristics. For example, we typically in the United States try to harvest rice between 18 and 20% grain moisture. And then, as you do in your countries, we have to dry that rice down for storage to about 12 to 13%. We do know that if we sometimes harvest rice at too high a moisture content, this can cause quality problems. Certainly, chalkiness increases when we harvest rice at too high moisture. And if we harvest rice at too low a moisture, this can, for a lot of varieties, significantly impact the milling quality, primarily the head rice. If we harvest rice down at 13 or 14%, we're going to have a lot more brokens, which is certainly a significant impact on the overall rice quality. We can have physical damage from a lot of different sources. We've got insects that can cause damage in rice, certainly stink bugs can cause peck damage. We can have damage by improper drying in the drying facilities, and this has been a significant situation this year. I think most of you have seen that Louisiana has had their share of hurricanes this year. So what this caused is we had a lot of rice that was harvested at kind of a high moisture, put into storage, and then because of the hurricanes, we lost power. So our farmers were rushing around getting generators and doing whatever they could to minimize the impact of the damage that can be caused by high moisture rice that we don't have air blown on. And we think we did a very good job with this. We think that most of our producers were able to get their rice dried, and in spite of all the issues they had to deal with from the hurricanes. And the milling characteristics, as I mentioned, moisture content at harvest really plays a role here, and chalkiness as well, both controlled by genetics as well as environment. We know that if the grain matures under very hot conditions, then typically with a lot of varieties, the chalk content is going to be much higher. Next. In amylose content. Amylose content is very, very critical. Amylose is a starch that can vary in the amount that we find in various types of rice. High amylose, the higher the amylose, typically the grain will cook less sticky, grain will cook drier. We understand that a lot of our customers in Latin America like a higher amylose. They like rice that cooks less sticky, and typically amylose varies from almost zero, which is little or no amylose, and what we call a waxy or a mochi type grain. Our medium grains normally have amylose about 13 to 16%. Most of the rice varieties that are grown in the southern U.S. have amylose from 20 to 25%. And a lot of the indica types that are grown in Central and South America have a higher amylose content, above 25%. So amylose, very, very important on how the rice grain cooks. Next. So another very important cereal chemistry component is gelatinization temperature. And that term means exactly what it says right there. This is the temperature at which the rice grain turns to a gel. And typically the indicas that are grown in Central and South America have a lower gelatinization temperature. Our medium grains that we grow in the United States Some in the south and the primary type of rice grown in California have a lower gelatinization temperatures, and our long grains tend to, the southern long grains tend to have an intermediate to a high gelatinization temperature. Next. So our rice breeders put a lot of emphasis on grain quality, and this is just an example of a system that is used to measure a lot of our quality parameters. This system can measure grain length, uniformity of grain length, which is very, very, very important, because if you've got a variety that say averages 6.8 millimeters in grain length, but you got some of the grains that are 7.3 and some of the grains that are 6.3, then that particular type of rice is going to cook much less uniformly. So you want to have a good grain length. We like to see our long grains in the upper 6 millimeters and approaching 7 millimeters. But we also understand that it's very important for that to be uniform as much as possible within the grain, within the variety of rice. This machine also measures whiteness and a number of other quality parameters. Next. So chalkiness is,
Entonces, el yeso es el gorila de 1000 libras. El yeso es el endosperma, es la opacidad, o lo que se llama el centro blanco, panza blanca. Es causado por la interrupción del grano fino.
Well, basically, as temperatures increase, both daytime temperatures and nighttime temperatures, the grain fills more rapidly. So if you know a little bit about biology and especially botany, you know that as temperatures increase, things happen more rapidly within all plants. So as those non-structural carbohydrates are moving out of the vegetative areas of the plant to fill the grain, at higher temperatures, the cells pack less uniformly. So when those cells pack less uniformly, you have more air trapped between those cells. And this is one of the things that causes chalk. So again, chalk is dictated by environment, but we also know that we've got certain varieties that typically, even under high temperature conditions, have less chalk. Next. And this is an example of a very chalky grain on the top and essentially no chalk on the bottom. Next. So this is what we'd like to see. We'd like to see very translucent grains. Next. But this is what you often see, again, under high temperatures with certain varieties when the grain exhibits quite a bit of this chalk characteristic. Next. So we mentioned grain dimensions earlier, very, very important. Length, width, thickness, and certainly the length width ratio is something that our breeders pay a lot of attention to. Again, as I mentioned, we'd like to have our long grains pretty close to 7 millimeters. Sometimes if we get much over 7 millimeters, we can have some issues in the mill because some of these very, very long grains tend to break more in the milling process. So again, our breeders shoot for the upper 6s and approaching 7 millimeters on our long grains. Next. And whiteness is very important. We were able to measure whiteness with the analyzer that I showed earlier. You know, we'd like to have a nice, bright white grain. Next. So this is just an example, and I'm using some of the varieties that we released from my research station through the years. Cypress was a variety that was released in the early 1990s, and it became more or less the standard for quality. We shipped a lot of cypress into Central and South America, and you can see it's got a very, very uniform grain, very little chalk. Cypress had a unique characteristic not to show much chalk even under high temperature conditions. And the other thing that cypress had was it kind of had the ability, even if it was harvested at lower moisture content of the grain, the milling yields held up very well. Chenier was a variety we released a few years later. You can see it's got a nice uniform grain, but it does tend to have a little bit more chalk than cypress. Next. So again, comparing cypress, CL111 is one of our very popular Clearfield varieties, where we use the Clearfield technology to control weedy rice and other weeds. And it is, again, has a little bit more chalk than cypress, but it's typically considered a pretty high quality variety. Next. And CL151, this is another Clearfield variety that was extremely popular. It was released in 2006, and it was very widely grown for many years. In fact, it was one of the most widely grown varieties for several years, and it's still grown in the southern U.S. long grain market. But as you can see, the quality of this particular variety is not quite what we would like to see. Quite a bit of chalk, does not have the grain length, but it had outstanding yield potential for our producers. So that's why it was very popular. So we're trying to get away from the CL151 quality parameters and move back towards something that emulates the cypress variety. This is what all our breeders are working towards. Next. And I just want to emphasize that rice breeders have always bred for quality. Next. So this is from the LSU rice breeding program. Dr. Famoso is going to speak to you next. And this is just these samples. We harvest milling samples at optimum grain moisture. Next. Bring them in. These are hand harvested samples that are threshed. Next. And move into our milling lab. You can see we've got very nice Brazilian Zachariah milling equipment there. So several months in the milling lab as part of the breeding program to look at all these quality parameters that I've discussed previously. Next. And I'd be happy to answer any questions. Again, it's been my pleasure to visit with you for a few minutes here this morning.
Muchas gracias, Dr. Lenskamp, por sus
Thank you very
palabras.
much, Dr. Linscomb, for your words. And I hope that you all feel welcome in this symposium. Continuing then with our agenda. Next, we will hear from our panelists and specialists. If any of you are interested in learning more about our speakers, please take a look at each of their biographies on the website of USA Rice, the website that was shared with you ahead of this symposium. And for those of you who did it already, we thank you. I'd also like to point out that following some of the presentations from our specialists, you will have the opportunity to answer a survey question regarding the topic being discussed. These questions are something like mini surveys to better understand the rice market and for us to have a little fun. Our first speaker, who will share his experience with us, is Dr. Adam Famoso. Dr. Famoso joined the Louisiana State University Ag Center, and formerly worked for DuPont Pioneer in the hybrid rice breeding program. This program focuses on all the commercial varieties of rice grown in Louisiana and southern United States, including Clearfield and Provincia. With that, we welcome Dr. Famoso. Thank you for joining us. The floor is yours.
Good morning. I'd like to thank USA Rice and everyone who made this opportunity available to us. This is a great opportunity for myself and the other breeders to share a bit of what we're doing and also get feedback on maybe directions we need to be moving in the future. My name is Adam Famoso. I'm a rice breeder at the LSU Ag Center in Crowley, Louisiana. I'm going to give an overview of what we do in our program here, as well as some of the new varieties coming out in currently and in the next few years. So our research station has been here for over 100 years. It's probably one of the most longest continuing running breeding programs, certainly in the United States, if not the world. We are in the southwestern portion of the state, kind of between Houston and New Orleans, to give you an idea. Our breeding program focuses on the different grain types of our industry, primarily long grain and medium grain. So long grain is our primary focus, and medium grain and some specialty types. When I speak of the different varieties, I'll break them out into herbicide classes. Really not very relevant for the end product, but it is how our varieties are typically classified here. So first is conventional, which is just our standard varieties that aren't resistant to any specific herbicides. The Clearfield technology, which many people are familiar with, and a more recent technology, the Provincia technology, which is a different mode of action herbicide. So I want to start just with what varieties are currently available from the Rice Research Station. Some of these were mentioned by Dr. Lincecum previously, but conventional, we have two primary varieties. Chenier, which is probably about over 15 years old now. It's still widely grown. Chenier might be familiar to some of our colleagues in Central and South America. It has a higher amylose type, and so the cooking properties are much more in line with what's desired. And Chenier has been used widely in our program as a parent to help ensure that those cooking qualities are passed on to our new varieties. In the Clearfield, Dr. Lincecum spoke of CL151, CL111. More recent varieties include CL153, which was released probably about 4 or 5 years ago. It's very widely grown currently in the southern U.S. This variety has a standard kind of U.S. southern cook type, intermediate amylose, intermediate gel temp. It has very good milling quality and is one of our lower chalk lines. The new Clearfield variety coming out from our station is CLL17. This was released last year, should be widely available next year. This is very similar to CL153. Provincia, we have PVL01, which was the first Provincia variety. PVL01 has a very long grain. It is very good grain appearance, very low chalk. Some of the issues that we see with this, as Dr. Lincecum mentioned, is with this very long grain, some of these grains are 7.4. We see a bit more for breakage. PVL02 was released last year and will be more widely grown this in 2020 and 2021. This is a long grain, also with intermediate amylose, intermediate gel temp. PVL02 has quite a bit shorter grain for a long grain. As was mentioned, we typically shoot for 6.8 millimeters, 6.9, 7. PVL02 is pretty consistently as a 6.5 millimeter. So definitely a bit shorter than where we want to be. And coming soon, PVL03, which I'll talk about momentarily. Okay, so first I'm going to go into some of the details with CLL17. This is the long grain Clearfield. This is anticipated to be widely available in 2021 in the southern U.S. Intermediate amylose type, very typical of our U.S. lines, 22% amylose. The Gel Temp is classified as an intermediate gel type, but many of these varieties are slightly higher gel type, intermediate based on the alkali spreading value ratings, but based on the quantitative numbers, it's about a 74.5 degrees gel temp. Milling is typically in the range of 60%. CLL17 compared to CL153 is a slightly shorter grain, pretty consistently at around 6.7 millimeters and a 2.7 grain length to width ratio. The chalk of this line is slightly higher than what we see with CL153. In the data we used for these presentations, we tried to take a test where everyone's materials were grown in the same trial. We have a test that all the public breeders in the US do together. So we took that from that test, and I will say we had much higher chalk values overall in that test. So I think the chalk values we present here will be a bit higher than what we typically see, but the environment certainly influences the chalk, but my observations have been typically a test might have higher chalk, but in general, the relative chalk values of one line to another don't change drastically. So just to put it in perspective, this line in this test, I'm reporting 16% chalk. In other tests of the same line is more typical in the 8 to 10%. But I think the general relative values do not seem to change much. But I can say that this line does have slightly higher chalk than what we see with CL153. So PVL02 is the second Previsia variety. This variety is be widely available next year. It's also an intermediate amylose, intermediate gel temp. The milling typically is quite good. On this test that we use for here is slightly lower, but it's a shorter grain for a long grain, and that often seems to help the milling of this line. I mentioned it's about a 6.5 millimeter, which is definitely shorter than where we would like to be with these varieties. PVL02 is just a much improved yield for this part of the state, which is why it was released and grown. Chalk overall has been very low in the Previsia varieties that we've released. PVL02 slightly higher than PVL01, but still very low chalk overall compared to our other varieties. So PVL02, as I mentioned, had some limitations in terms of the grain quality, and we intended for it to be a kind of short-term variety, and we are now about to release PVL03. PVL03 kind of maintains the high yield that we were able to get from PVL02, the improved yield, but it also gets back to a nice long grain length. Also has some improved disease resistance, which will help our producers. So this variety is currently being increased in winter production, both in the southern United States and in Puerto Rico. We intend to have limited seed for 2021 and large-scale seed for 2022. This line is a intermediate amylose in the range of 21 to 23%, also intermediate gel temp. In the data we've had so far, pretty consistently have been very good milling and a very nice grain length consistently at 7 millimeters or longer. Chalk has been good as an overall variety, slightly higher than PVL01, which is very low chalk, but the feedback we've had on the grain quality of this line has been very positive. I mentioned it's intermediate amylose type. We also have versions of this that are about a year behind that are going to be more like the Chenier type, slightly higher amylose, up over 25%. So it's very possible we'll have a higher amylose version of a Previsia line in the next 1 to 2 years to follow this one up. The next variety I think was probably of the most interest to the Latin American export community is a conventional line that we're testing as LA2126. This is a conventional long grain, has high amylose, up well over 25%. It has an intermediate gel temp. We've seen very, very good milling on this line, a nice long grain at or above 7 millimeters. When we compare this to some of the other high amylose types that we have in the US, we do see some improved chalk. Overall, its chalk is similar to CL153. So I think this is one we've sent out to some people in the United States to take a look at the grain quality. If any of the participants here would like a small sample, we have very limited sample of this, but we could try to send at least enough to maybe cook a small bit or get a look at that. But this is something we're in the process, initial purification and seed increases. It's possible that this would be commercially available in 2023 as our kind of first high amylose line out of the LSU program in some time. As was mentioned at the beginning of the symposium, the process of breeding these lines is often 7+ years, and so this variety would be one of the first where we're going to be getting things out from efforts that we started around 2015, 2016 to start incorporating some high amylose focus in our breeding program, and since that time, it's each year this high amylose class is getting more and more attention. So I think this is the first of hopefully many varieties that will be delivering that have the high amylose and desired cooking characteristics. As I mentioned, we are doing more and more, and starting in 2018, we began trying to focus on materials specific for what we believed was desired for the export market. So we started with the idea of high amylose and low gel temp, as was mentioned, is often the varieties in Central and South America have these characteristics, and then low chalk. So in 2018, we began a pretty significant effort in this space. And in 2020, we had 140 lines that met those criteria, and we put them into some trials in the field. This material was developed both by crossing 2 US lines. One was a high amylose line, and one was actually a jasmine type line. The jasmine material is very low chalk, US jasmine line, very low chalk, and it provided the low gelatinization temperature. And then the other US line provided the high amylose. And we did a lot of selecting in the lab to find lines that were fixed, that had high amylose, low gel temp, and our goal was they would have those characteristics, but also maintain the low chalk from the jasmine line. So this year we tested 140 lines. We've identified 40 lines based on the grain quality, appearance, high amylose, low gel temp, and a 7 millimeter grain or over. These lines were very low chalk. Almost all of them were less than 5%, which is significantly lower than what we see in most of our U.S. varieties. So we are very hopeful that at least one variety could come out of these materials. We still have a few more years of testing with these. We still need to look much more closely into the actual cooking characteristics and parameters, but this is a direction we're shifting more towards, and hopeful that something will come out of here much more similar to the desired cooking characteristic type. So future efforts of our program, I mentioned, we're putting, each year we're putting more and more emphasis and focus on high amylose, both in what we cross in our breeding program, which again, what we cross today will likely take 7+ years to have a product, but it's giving us more material to work with. But also, we're putting more emphasis on what we advance, certainly taking into consideration the cooking characteristics. We obviously have to have high yield in our varieties for our industry, but we're putting much more emphasis as well on the grain cooking parameters beyond just the milling. Some of our breeding priorities going forward are focusing on a non-sticky cooking, a longer grain, and lower chalk. And we feel pretty confident that our breeding germplasm base as a whole has all of these characteristics. It's just a matter of us prioritizing and evaluating and advancing lines on these materials. So, as I mentioned, we think it's possible we may have a variety that's much more in line with these targets as soon as 2022. And as I mentioned, we have small samples of some of these different types that we would be able to share, maybe a couple 100 grams or so, to have enough for someone to cook. I think, and later in today's symposium, a graduate student, Raul, from our program, had a big focus on this whole area where we're just trying to better understand exactly what we should be breeding for, and a huge part of that is going to be feedback. We've had some very valuable visits from some folks who've given us the initial kind of articulated the initial importance to us, and honestly, that's a big reason we started this a few years back and have kind of continually ramped up. So we understand the importance, the value. We're kind of, as we go, trying to develop varieties, but also better understand what exactly the targets are. So anyone who would be interested in giving us feedback, collaborating with us, we would be very interested in sharing our milled rice of samples to kind of get some feedback on if we're moving in the right direction or what qualities are preferred to help us on this journey. Certainly a long-term process, but I think what I'd like to leave you with is that it's something that we are taking very seriously and putting a lot of effort to, and we've made some progress in recent years, and we're hopeful and confident going forward that we'll be able to continue that. So with that, I will stop, and I'd be happy to take any questions or comments. Thank you.
Bueno, gracias, Dr. Famoso.
Thank you, Dr. Famoso. Now, let's go on to the questions. Here we have a question in the module of questions and answers that says,
more expensive in cost than actual ones, or there are more and more private labels and brands at entry price point category brands in Louisiana to the market director. So will there be more expensive costs? And what are the costs?
I don't think as a flat statement they would be more expensive. I think the question that will come up is, we feel confident that we'll be able to get varieties in the short term that will be much more in line with what's desired. I think the question will be, what will these varieties yield relative to our top yielding varieties? And so it's possible that if we release a variety that has slightly lower yield or lower yield than what's out there, there might have to be some type of premium or something like that for the growers to be able to grow it. I don't think the growers will grow these varieties if they're going to get lower yield and not get compensated. But I think the varieties that we are coming out with we've got many things that are on par in terms of yield. So I think that would just mainly be a question of just how do these varieties perform in terms of yield, and if a variety is of such higher quality and desired, maybe people would be willing to pay a bit more to ensure that it's grown. But that would be, I think on a case-by-case basis.
Thank you, Dr. Formoso. Another question that we have is, can you share category campaigns that you've done in other countries that we could use to increase the relevance of rice versus other food options? And
I think that's probably outside my
That's
area.
a question for USA Rice, and we'd be happy to share. Esa es una pregunta de USA Rice y
Esta es una pregunta. That's a question from USA Rice, and we will be happy to share about the campaigns that we are doing to push the US rice in other markets. And to have a larger conversation about that, please write to my email at Grisby at usarice.com, and we'll be able to share ideas to increase the campaigns about US rice in other markets. Another question we have, these new varieties as a result of the rice breeding, what can be the difference compared to current cost?
Okay, just give us 1 minute. So I'm going to just give Dr. Formoso a little translation here. For the new varieties, what is the breeding process that can be what's the different breeding process that you use to change the differences in price, to make the difference in price?
So as far as the breeding process that we've used in the recent years, not necessarily related to the price, but the time. So we do utilize DNA markers. Fortunately, the traits that are very, very important for the cooking qualities are amylose and the gelatinization temperature. And we have the capacity to screen these lines based on a piece of leaf and be able to predict if it's going to be high amylose or lower amylose or low gel temp or higher gel temp. And this allows us to move much faster. So the example of the materials where we had the 140 lines this year, those were crosses that we made just 2 years ago in 2018 and screened over 6,000 individual plants at the seedling stage to hand pick the roughly 150 that were of the desired quality profile. And then from those 150, we did a seed increase and some visual breeding observations and entered 150 into our nursery in our yield test this year. And then from those 150, now we're narrowing it down based on more of the cooking parameters. But I would say that the process of the DNA markers has very much facilitated these activities. It doesn't get us to the end product, but it allows us to get, it allows us to throw away everything that we know is not going to be desired. So in this case, we know we are not trying to get intermediate amylose. So it allows us to say, this line is going to have intermediate amylose. Let's not waste our time on it. And then now we're narrowed down, and now we need to do more detailed analysis on these final 40 or 50 lines. But I think that has probably been the biggest breeding tool for us to be able to respond in relatively short number of years to try to meet this market need.
Thank you, Dr. Famoso. And we have just a few more questions. Tomen en cuenta, por favor, que después de ese
Please
breve
take into consideration that after this brief space of questions and answers, we're going to have a longer space at the end, 20 minutes, to answer the questions that we might not have the time to answer now. So please don't worry.
Famoso, a few more questions. We still have you for 7 more minutes. How do these varieties yield at producers' fields?
So some of them are, and some of the stuff in our middle stage of testing is some of our highest yielding stuff in our test. But overall, I'd say it's probably a slight reduction in yield in the material we have now, maybe within 5% of what our varieties are. Again, that's pretty typical, I think, when you start breeding in a new breeding segment. The focus in this case has got to be on the quality, because that's what's going to define this segment. We need to be competitive on yield, but right out of the gate or from the start, it might not be, it's not likely they'll be the highest yielding varieties, but we just want to make them competitive. So some of these varieties in our small plot trials are pretty routinely yields, I'd say 8-9 tons per hectare in our environments here, which is slightly below what we see with some of our most recent, say, Clearfield varieties, for example.
Excellent, thank you for that. Another question that we have is, will we be able to develop qualities similar to Olimar or Takauri from South America? And in what time would these varieties be able to go into the market?
So certainly Olimar is a kind of a target for us. The question, I guess, is 2 parts, and one thing that's not clear to me, at least, and maybe it is to others on here, is if we grow Olimar in the United States, does it come out as the same quality as what you see if it's grown in South America? There is this environmental piece to the rice. So when we grow Olimar here, it is very low chalk. We haven't done all the cooking characteristics, but later Raul will speak at the end of the symposium, and I think go into a lot more depth of how we're trying to understand some of these more fundamental questions in terms of the quality. This is a project that support of USA Rice has enabled, but we're trying to ask a lot of those questions of, okay, if we grow Olimar here, for example, what is the cooking profile versus if we get a sample of Olimar grown in South America? And when we're doing the comparisons for kind of setting our breeding targets for the future, we are sourcing rice from the country, whether it's Nicaragua or Costa Rica or Uruguay. We're getting rice from there that's considered high quality, and we're comparing the cooking characteristics to what we're growing here. So we're not necessarily trying to compare variety to variety. It's more of, can we produce things that are considered or similar to the high quality rice that's produced in the country. So it's not a real direct answer, but it's something that we're kind of kind of working on to better understand ourselves.
Muchas gracias. Excelente. One more question that we have time for. At what grain length will you see more breakage in the milling process, or what is the max grain length for better milling results?
The only thing that I have real firsthand experience with is the PVL01, which, like I had mentioned, is about a 7.4 millimeter grain. It's very long, very slender, very nice grain. We see more breakage with that variety, and I don't know if it's just because it's longer or because our mills are set and optimized more for a grain length in the upper sixes. So if we were to adjust our milling, maybe we would get better results. But just looking at the grain, you can see why it would be more likely to break, just how long and slender it is. The variety I mentioned that we're in the process of releasing through Horizon Ag, PVL03, that variety is pretty consistently 7.1 millimeters, and we have not seen any issues or concerns with breakage. So where exactly that cutoff point is, I'm not sure, but we do, as a general trend, see the longer grains are a bit more prone to breaking during the milling process.
Great. Dr. Formoso, one more question before we move on in our agenda. Can you give a small explanation of the breeding process? There's still some confusion with GMO.
Sure, that's a great question. So what we do in the U.S. in our program, but also I think every program in the United States for rice, it's all non-GMO. Basically, we're following traditional breeding in the sense where we take two parents, one that has, say, good attributes of, say, yield, and you cross it with another parent that maybe has other good attributes, say, in quality. And the goal is to cross two things and select among the progeny, the children that come out of that cross, so to speak, and try to identify progeny that have better characteristics than both the parents. And in the United States and at our station here, this process has essentially been going on for 100 years. And we just continually take the best parents or the best lines or varieties, and we cross them to each other, and we try to recover progeny that are higher yielding, higher quality, better agronomics. But it's completely non-GMO. There's no efforts in our program, or I believe in any of the applied breeding programs in the United States for anything genetically modified in rice.
Thank you so much, Dr. Formoso. Muchas gracias, Dr. Formoso.
Thank you.
Y muchas gracias.
Thank you very much, Dr. Formoso, and thank you all for all of your questions. If there are any more questions, please do not hesitate to share them at the end, but please use the Q&A module so that we can organize them better. Very well. Now we have our first survey. You can see on your screens a question. This is survey number 1. Please answer according to your knowledge. I'll give you a moment to answer. And in a few seconds, we will see the results. Okay, let us see the results, please. Excuse me, I'm going to give us a few more seconds. We have had 30 seconds out of 90 participants. Certainly. Another minute is no problem. Think carefully about your answer. Well, let's see what the right answer would be.
Okay. Parece que
All right then. It would appear that most of you chose China. And congratulations, China is the right answer. So congratulations to 44% of our participants who selected China. Thank you for participating in our first survey. Continuing with the agenda, next we will have Dr. Wei Shah. Dr. Shah is a professor and rice breeder at the Ag Center at the Division of Agriculture and is part of the system of the University of Arkansas. Dr. Shah has done various kinds of research. All right, Dr. Shah, the floor is yours.
Good morning, everyone. I thank US Rice and you all gave me this opportunity to give you a brief introduction of the rice breeding in Arkansas. And also we going to be later on give some detailed description on the latest variety or the a few potential, not a potential, it's going to be released in the future for the quality aspects, how they're going to fit your needs in the Latin American countries. As Asia side, my name is Xuyan Shaw. I'm a rice breeder and a professor at Rice Research Extension Center in University of Arkansas System Division of Ag, which is located in Stuttgart. If we know the Arkansas, it's about 60 miles southeast of a capital city, Little Rock. I got my PhD in plant health with agronomy minor from Louisiana State University, or LSU. Prior to my current job, I worked 12 years as a rice breeder at LSU Ag Center with Dr. Steve Linskeman. He's my mentor and my boss. My breeding research focused on the genetic improvement of a medium grain and a long grain rice for higher yield, good and a stable milling, acceptable grain quality and appearance, biotic, abiotic stress, heterosis, which primarily for hybrid rice, and also the Clearfield and recently the Pavizia rice breeding. During my career, I am responsible for the release of 9 rice varieties for southern US, and also I co-released another 18 with my peer rice breeders. If you pay attention for the US rice industry, Arkansas ranks #1 among the 6 major rice growing states, account for about 45% of US total rice production annually. And on the left-hand side of the bottom, you see the map of the United States. Rice is a relatively small crop, very concentrated. It's primarily in the Mississippi Delta, which including Blue Hill, Missouri, east part of Arkansas, northwest part of Mississippi, and the northeast part of Louisiana, and also some area around the northern Gulf of Mexico, Louisiana and Texas, and also in the Northern California in Central Valley and Sacramento Valley. On the right-hand side of the map, this is the map of counting map of the state of Arkansas. You can see rice is a very important crop in Arkansas, being grown on 40 of the total 76 counties in the state. The biggest rice growing state counties in the state, including Arkansas County. You can see a star here. That's where my research extension center is located. Some major rice growing county in northeast part of the state, including the Cross County here, the Poinsett County, and the Lawrence County. About 80 to 90% of the Arkansas rice belong to long grain. The 10 to 20% depends on which year medium grain rice. Hopefully you can see it. The next will be a little history of the rice breeding in Arkansas. We have a very comprehensive breeding program working on both inbred and also the hybrids of all marketing class, long, medium. I didn't list the short grain here, but also working on the aromatic rice. It's a long history for the rice breeding in Arkansas. Breeding started by USDA scientist, Dr. Lloyd Adele in 1936. Since then, about 54 rice varieties have been released. 38 of them actually in the last 40 years since 1980. Arkansas variety normally occupy about 86% from the high of the total Arkansas rice acreage to roughly 20% in recent years because the wide adoption for hybrids, Clearfield and the Pavizia rice from the private industry. In 1980, that's a big milestone for the Arkansas rice research. The Rice Research Promotion Board established, started fund the university rice breeding program. The first university rice breeder was Hyde in 1980. He actually gonna give you a talk later on today, Dr. Kent McKenzie. In 1991, the second rice breeder was added to the program, focused on the medium grain and a semi-dwarf long grain. In 2001, the molecular laboratory added to working on the market assistance selection. We also continue on the anthroculture, try to hasten or to speed it up the breeding process. In 2003, Riceland Foods quality laboratory starting screening breeding material. Riceland Foods, of course, is the largest U.S. rice co-op. Their efforts can help us to ensure whatever we develop to meet the quality standard or specification by the major exporting markets, also the industry. In 2010, we also added the aromatic and the hybrid rice breeding program. Over the years, about 13 breeders, in total 13 rice breeders working in this center. 4 of them are underlined, which means they are current rice breeder. The first one, Dr. Karen Moldenhau. She's a senior rice breeder. She got a very long and distinguished career. She just announced the retirement. Then, of course, in May, I joined the program in late 2012 from LSU. Working primarily on the medium grain and also the short stage for long grain. Dr. Hassan Shakiba. He joined in 2012, working on hybrid rice. Most recently, we got a new addition, Dr. Christian de Guzma. He's going to take over Dr. Karen Molenhouse long grain breeding program. The breeding objective or breeding goals for us always quality. As Dr. Adam Famosa talked about, Dr. Steve Linscomb talked about, quality always the priority for us. Try to maintain and improve the cooking quality, to increase the grain length. We want it to be 7.2 millimeters. Try to minimize the chalkiness. Also, recent year, we try to increase the product, the diversity, add a specialty rice for some niche market and of nutraceuticals in the future. For the yields, we're working on higher yield potential, not only the rough rice, but also the milled rice. We focus on the plant type, stay grain, the erect plant type, stiff straws. For the Arkansas, because the rice being growing in such a diverse, relatively speaking, growing conditions, so the stability, yields and milling stability always the emphasis for us. In the future, we try the integration of the high yield QTLs and genes. On the biotic abiotic stress, we try to have multiple resistance, combine different resistance into the same genotype. Try to discover, incorporate a new source of blast resistance and also sheath blight tolerances. Working on cold tolerance primarily for the seedling figure. And for the long term, we try to work on the salt and the drought tolerance. Early maturity always one of the objective. Want to range from 90 to 135 days. Most recently, the water conservation is a hot topic here. So lots of furrow irrigated rice or row rice and alternate wet and dry rice. We try to utilize all the new technology, computers, genomics, try to speed up, improve the efficiency of our breeding operation. This just gave you a bird's eye view of the breeding activities. Early on, somebody asking a question about the GMO rice. We never had any GMO rice in this research center. Everything is traditional. The breeding starting making cross. You probably see here, this is my program. We are chosen to the best genetics, or not only two, multiple genetics, try to combine, to incorporate, try to come up with new variations. So in this setting, we, because the rice had a perfect flower, so we have to emasculate the rice, then have control or plant pollination. So we be able to make mass produce over 150 crosses a day with a team effort. So after the cross made, we go through all the progeny tests, advancement, and the selections. We put out the year trial, try to make sure the variety have very wide adaptation and stable. Everything is highly mechanized on the breeding efforts. We use a GPS guided tripping and planting, the automated weight and a moisture capture system for the harvesting, small plot combine. So everything is very efficient. Quality is a central part of our breeding effort. You probably saw Steve's slides. So we got this Zachariah from Brazil. This machine had a test mill, had some issue, but in general, it's very efficient. Only take about 2 minutes. Can mill a sample only by one person. So compared to the McGill, gonna take a 2-person, longer than 2 minutes to do a sample. So it's very efficient. Milling, we use a small sample from the progeny, normally starting from F4. Some cases we are also evaluating as early as F3 generations. We mill a small sample, use this Zachariah machine about as low as 25. So you can see the milling, the grain appearance, the uniformity of the grain. For the advanced line, we do use the wind seeder. You're gonna hear me talk about a wind seeder later on. We do the more accurate, larger scale determination of the grain dimension and chalkiness. We also use a marker. In this case, we use a snip marker for the cooking calculus, serial chemistry. In this case, they got a waxogen on the left-hand side. Then got an alka or gelantization temperature traits on the right-hand side. Next, I'll talk about, I'll give you a little bit detailed discussion on the new variety, 2 new variety, and the 2 recent released variety on the cooking characteristics. This first one, the CLL15, this is a Clearfield, long grain, semi-dwarf plant type. Got a good and a stable, relatively consistent yield potential, very good at milling. Got very good at varietal resistance with a PETA and a PIK. This already in the commercial production this year. It's marketed by the Horizon Air. All these data provided by the milling and the chalkiness measure and the picture kindly provided by Dr. Formosa. Appreciate his effort. The milling, you can see it's about 62.7 hit rise, 69.1 total rise. Chalkiness, you hear early on, we got different measures, different instrument. They gave you different results. The first 14.8 is a seed count. Use the same sample as Dr. Formosa's. It's done by him. And the riceland foods, they also use a visual inspection, which follow the procedure by the FGIS, or Federal Grain Inspection Services. It's 1.3%. The USDA ARS, they also use the wind seeder to determine it's a 7.4. So I didn't put any comparison here, but much better. Regardless, it's much better than CL151. It's more close to the CL111. The milled whole corner dimension, when the seed count gave 6.9 millimeter. The width is a 2.4 millimeter. The length to width ratio is 2.9. The riceland foods also use a manual caliber to take the measurement. You can see the length is about 7.1, the width about 2.1, length to width ratio is 3.4. So they're a little bit different. The amylose contents, it's about 8 different samples, average about 22%. Gelantization temperature 70.4. The meal rice uniformity is on an average. The RVA profile, it's also an 8 sample average. The peak, we use the RVA unit, which is different from the centipoises. You hear the CP. This is about 1 unit equivalent to 12 CPs. So peak RVA about 233, trout or the hot RVA 126. The breakdown is 1 out of 7. Final or the cold RVA is the 237 and setback of 4. Next is CLL16, also Clearfield long grain. This is came from Dr. Karen Moldenhaus breeding program. This line, this new release, it's well getting to the commercial production next year. It's already released, will be marketed by the Horizon Ag also. This have a superior, very superior yield potential. Got a conventional height with a very erect plant type. Have very good disease resistance too, with PETA and a PIK for the blast resistance. Got a very stiff straw. Got an excellent yield. The milling for CLL16 slightly low compared to CLL15. The total rice is very similar. The chalkiness is a little bit high here. I suspect maybe lots of immature color because the CLL16 is relatively light. The rice length food gave the estimate of 2.1. In reality, this CL16 is preferred by most rice mills in the USDA rice quality task force, which they evaluated not long ago. So it's very good quality, very beautiful kernels. The mill rice dimension, the length is about 6.9, the width about 2.5. The length and width ratio is 2.8. But I use a caliber, you can see the length to width and the length to width ratio a little bit longer and larger. Early on, the question asking about how long the kernel going to be not affect the milling. We talked to the rice foods here. They wanted something. It's relatively more bread, have a higher breadth or higher width. Because they don't like a skinny kernel, very long, which is easy to break. You can have long kernel, but much relatively wider, or they maybe retain the milling percentage. The amylose contents are the same thing. We average 8 different samples, so 23.1. Gelantization temperature a little bit below 70 degrees. The mill rice uniformity very on the average too. The RVA profile is very similar to the CLL15. So it's a typical US long grain. Joy is our another new release. We'll enter into the commercial production next year. It's a public release. You can see it's also very erect. Conventional height, stay green, typical Dr. Karen's Moldenhaus plant type. Got very good yields, very good milling, very good disease package also with PETA and a PIK for the blast resistance. The quality, you probably can see a little bit, there's slight difference compared to the both CL15 and CL16 on this jewel. The milling showing slight low here, about upper 50s on head rice, close to 70% of total rice. Just chalkiness, 18.5 on seed count. The visual inspection about 2.6. The wing cedar is 6%. That's very low for the wing cedar score. So it's a beautiful cono. The dimension, the length on the seed count is 6.7, and the caliber measure is about 7.1. Length width ratio, even the seed count is showing the 3.0. On the menu caliber measure, it's about 3.4. You see the amylose contents here is a 25.4. It's over 25%. This is also 8 sample average. Gelantization temperature 71.5. But the jewel have a weak RVA. We call the L202 type, or just like chenille, cooking type. You probably can see the RVA score got low peak RVAs. The trial has a low breakdown, also low. So this may be the one which showing very good potential for the Latin American market. As I mentioned early on, we're also working on the jasmine type, aromatic long grain, Aroma 17. This is a variety released several years ago. Got a very good yield potential, very good milling, very erect, stay grain plant type. The milling in this uniform test is showing a 69% head rise, 73% total rise. Chalkiness is very low, is 9.1 in seed count, 1.6 in the wing cedar by the USDA. That's almost no chalky. The middle corner is very slender, long corner is 7.1 even on the seed count. The amylose contents you bring and see, this is the jasmine type. It's a 15.8. Gelantization temperature also low, it's at 62.3. The RVA profile is different. You can see setback is minus. So that's what I had. We are working very hard, try to come up with the rice fit your needs. We can discuss that in the later. This is my contacts. This beautiful building is our research extension center. If you have any questions, I'd like to entertain. Thank you.
Muchas gracias, Dr. Shah. Y ahora vamos a las preguntas que tenemos.
Thank you so much, Dr. Shah. And now let's go to the questions that we have.
The differences in chalkiness percentages, 14.8% versus 1.3%. Why so much variance?
Yeah, I guess they measure different things. It's not apple and orange in this case, and not apple compared to apple. I believe the seed count, Dr. Formosa probably need to correct me if I'm wrong, or Dr. Steve Linskerman. They measure the overall opaqueness of the whole sample, not only by a single grain. While the there's a visual inspection based on the Federal Grain and Inspection Services, they count how many grains showing the chalky. They classify a grain with more than 50% chalky. They consider the whole grain as chalky. So if we get 100 grain, only one of them showing over 50% chalkiness, then they gave you a number, the 1%. So on the other hand, the seed count, you got overall opaqueness of the whole sample, whole area. So that's the difference. I don't know if I explained well.
Bueno, muchas gracias.
Well,
Dr.
thank you very much, Dr. Shah. Now, for the questions that we're not able to answer now, please, we're going to have a space at the end to answer all these other questions. And now we would like to welcome Dr. Ed Redoña. He's the only rice breeder in the state of Mississippi. He obtained his MS and PhD in genetics from the University of California, Davis. He has over 2 decades of rice breeding experience. He has developed several rice varieties, both conventional and hybrid. Welcome, Dr. Redoña.
All right. Good morning, everybody. First of all, I would like to thank USA Rice for allowing me to share our efforts on rice breeding here in the state of Mississippi with our most important target market, Central and Latin America and the Caribbean. My name is Ed Redoña, and I'm a research professor here at Mississippi State University. And as mentioned, I have the distinct honor to be the only rice breeder in the great state of Mississippi, where I've been since 2014. Before that, I used to work as rice breeder at Erie and has visited also Central and Latin America in my role as the former global coordinator of the International Network for Genetic Evaluation of Rice at Erie or INGER. Today, I'm going to talk about rice in general. First, in Mississippi, and the crop is grown in 259 farms, mostly in the Mississippi Delta counties, and this has been so for the last 10 years. The practice, the cultivation practice or method is dry direct seeding. And the rice industry is considered as a $100 million US industry, with the production numbers in 2019 as being 433,000 metric tons in terms of volume, with a value of $101 million US dollars. In terms of rice area and yield, the area over the last 10 years has been fluctuating, as you can see in this graph, and mainly it is fueled by a number of factors, not the least of which is the market price. The yield average, the average area has been 146,000 acres, which translates to 59,000 hectares. And the average yield in terms of the metric system is 8.07 metric tons per hectare. A very high yield compared to some of the other rice growing countries worldwide. The varieties grown in the state are all long grain. Basically, of the 259 farms, hardly anybody plant any medium grains. And that's in terms both of hybrids and inbreds. In terms of rice research, the research station is for rice is the Delta Research and Extension Center in Stoneville, Mississippi. Some of you may be familiar with Stoneville. It's also a location of the USDA, and in fact, it's very famous for cotton early on, and probably is the largest, if not one of the largest agricultural experiment stations in the US. In terms of the areas of research at the station or DREC, we have breeding, rice agronomy, weed science, plant pathology, entomology, water management, and economics. And all of these research activities are funded mainly by the Mississippi Rice Promotion Board, and involves not only research on station, but also off-station sites and external collaborations. In terms of rice breeding, the breeding activities, focused breeding activities has been going on for 34 years. I am the fourth breeder to head the breeding program. And we have, for breeding experiments, we have roughly about 60 acres in Stoneville and 6 other locations in the state. And recently, the breeding program acquired a new seed and grain laboratory, a new greenhouse. It's actually not new, but it used to be owned by a private company that has now the facilities were acquired by the university. And coming to the products developed by the program, we have released 8 varieties. 6 of them conventional varieties and 2 Clearfield types. On average, we release, or the program has released 1 new variety every 3.9 years. And our economists did some impact studies on the most popular conventional variety released by the program, named Brex, which at 15% of the market share in the state delivered an impact of 1.36 million US dollars per year. So very good investment for rice growers who support our breeding program. So you might be interested as to what we are aiming for, and I write here, and it's translated into Spanish as well. The goal is to develop high-yielding varieties with tolerance to biotic and abiotic or environmental stresses, and with grain, milling, and cooking qualities required by our target markets, both domestically in the US and abroad, and principally in Central and Latin America and the Caribbean. So when I came on board, I basically divided our targets into what I call as producer traits here, and I'm sorry about that. Producer traits and end user traits. So for producer traits, we aim for high yield, wide adaptation, latching resistance, tolerance to biotic stresses as mentioned, which includes drought, heat, salinity, and cold, herbicide tolerance, exemplified by the Clearfield technology, and of course, desirable plant type. For end user traits, which I know many of you are interested, we aim for high milling quality, both in terms of milled and head rice, translucency and uniformity of the grain, and all of which primarily long grains, very low chalk level, and cooking qualities depending on the target market that we are aiming our varieties for. And one of the main focus is to have of our program has been to develop serial chemistry profiles that also are useful to industry, primarily in the parboiled and microwavable product development in terms of microwavable product development. So I know some of you are interested in how we do breeding. The primary method we use is we call as classical pedigree breeding. It's in our case takes about 8 to 10 years to develop a new variety. We use Puerto Rico as our winter nursery to be able to plant at least 2 times a year. And other methods that are in use are single seed descent or rapid generation advance. There has been mention earlier of DNA markers. We do use that a bit. And no GM or genome editing technologies are being used. So in terms of our pipeline, so we have, as I referred to earlier, we work on conventional type varieties as well as Clearfield type varieties. So about 2/3 of our program are devoted to conventional type breeding. And about 1/3 aims for development of Clearfield and maybe in the future Provincia type lines. And in both of these pipelines, we have high amylose types and dual purpose, that means used by industry, and sometimes referred to as Nurex types embedded in both the conventional and Clearfield breeding pipelines. So as you can see, breeding is like from the moment you start to cross, then it goes into several generations, and then it's like a sieve, and then finally you come up with fewer and fewer lines for the final yield testing. And I just show here the number of locations we use and the number of lines that are progressively tested or sequentially tested in this sieve that I show. And on any given year, over the last 6 years, we test roughly 2,500 fixed breeding lines. And from that, in the final test, we would only probably test 16 and release 1 or 2. So you can see the effort that's devoted to coming up with a single breeding program from the initial test in terms of yield down to the final testing. And in each of these tests, we include rice quality evaluations. And you've seen this picture quite a bit in the past 2 presenters. So this is what we do in-house. We also have the Zachariah Lab rice mill for evaluating milling quality of samples. And we also have the wind seedle system, image analysis here for analyzing the level of chalk or chalkiness. In addition, we collaborate with USDA through the URN in analyzing physical, chemical, and molecular marker. We're doing molecular marker analysis, and I show here a spreadsheet or some data on some of the things that they do or are done on our materials here at USDA. That includes determining alkali spreading value and using markers for amylose, etc., aroma, and also evaluating another level of grain quality evaluation by others, not just in-house, using the wind seedle system for length, width, and length-width ratio. So, and then before a variety is released, we in fact test them in different locations in Mississippi. And on any given year, we would have roughly about 6 to 7 locations where the prospective varieties are evaluated not only for yield, as shown here, but also for milling performance. So we make sure that whatever we release actually satisfy the end user traits that I mentioned a while ago, primarily milling, whole milled, and head rice recovery, and also low chalkiness. So once any given entry or breeding line is advanced to this test, then finally we do an official release if it performs well in the final tests, and that particular line then becomes a new variety. So in the next few slides, I'll give you three varieties or potential varieties that are in the pipeline. So the first one is THAD. THAD is a new Mississippi conventional variety. It's derived from some of these varieties that you may be familiar with, primarily Nurex. So this new release has a very high yield. It is early maturing, it's semi-dwarf, an excellent straw strength, has some resistance to bacterial panicle blight, and moderate reaction to straight heads. So all of these traits allow us to promote this variety to Mississippi rice growers because these are some of the traits they want. But in addition, this variety also satisfies some of the requirements of millers, like it has a very high, it has high total milled rice, and I'm using here an average of 4 years of data, 56% whole milled, 69% total milled. And again, using the same set of data, the measurements are, as you can see, milled rice is very long and well, very typical of long grain, southern US long grain varieties. So in terms of cooking quality, this variety is very unique. It has high apparent amylose, which is preferred in your market. A gelatinization temperature classified as intermediate and a spreading alkali spreading value of 3.2. But the special trait about this new variety is it has the Nurex amylose type, which translates to strong pasting property on an RIBA profile that makes it superior for use in parboiled and canned and microwavable rice. So this having these characteristics allows this new variety to have great potential for capturing value in identity preservation markets. And in addition to those traits I mentioned, before this variety was released, it was subjected to a milling evaluation by major US rice mills and exporters that I haven't identified because this was actually coordinated by USA Rice, and it was a double-blind test where the mills didn't know what they were testing and where it was coming from, and the breeders didn't know which mills was rating which variety. So everybody was blind except for USA Rice. And during that batch of tests conducted in 2015, THAD was the only variety highly rated for grain traits. And these are the traits: milling, processing, branch streaks, chalk, kernel color, uniformity of length, overall appearance. And that was the only one that garnered unanimous acceptance by all of the major rice mills for use for their own purpose, whether it was local or domestic or export. So this gave us confidence to really release THAD as a new and a major Mississippi variety. And in fact, currently it is being used by industry in development of parboiled and microwavable rice products. Okay, so coming to future releases, what I show here, I'm sorry, let me just backtrack a bit. what I show here is a potential release, a new line. It's called, at this time, it doesn't have a variety name, but it's RU16041993. I'll just refer to it as 4193. And it's scheduled to be our next variety release by next year. This line is a typical southern US long grain. It is derived from Chenier. You've heard about this line a lot in the earlier presentations. It's very high yield. So in fact, if you look at the yield levels, it's comparable to Rex and even out yields that by a few bushels per acre. It's early and a little bit on the tall side in terms of plant height. So I think this variety will also satisfy the needs of our growers in terms of producer traits. Now coming to the end user traits, this has very superior high milling recovery or milling potential in terms of both hold. In fact, if you take a look at this graph here, it outperforms both Rex, which is the #1 variety, conventional variety in Mississippi, and THAD for whole milled rice, also, and not only for whole milled rice, but also for total milled. And the average of 14 trials, 14 is given as such a 58% and 71%. Now, in terms of the grain traits, sorry about that. Grain traits, again, using data of 4 years, this is a very, the typical or on the higher sixes in terms of length, grain length, and length width ratio is 3.2. But one of the most striking traits of this potential or the upcoming release is its very, very low chalk. So you can see here, THAD already had a very low chalk at 5.9% across multiple years of data. And this one is even lower and even is better than Rex, our most popular conventional variety, and THAD for average chalk using 4 years and 14 trials of data. So we hope to be releasing this next year. And like I mentioned, it has the intermediate apparent amylose content and gelantization temperature of intermediate, both of which are typical traits or classifications for USA long grain rice. It's also very white, as you can see, both in terms of the unmilled and cooked form. And again, a major characteristic of this potential release is the fact that just this year, earlier this year, USA Rice again conducted the same milling tests involving this time 10 major US processing, milling, and exporting companies. As indicated here again, I did not write the names, but they again rated 17 entries, 17 from 8 released and 9 potential conventional and herbicide tolerant varieties from 4 US public breeding programs and the private sector. And as you can see, and I won't go into the details per se, but the average score for this line, 4193, was higher than the average score of all the other 16 lines combined. And for one particular trait that the question was, is this an acceptable long grain variety for your purpose? And 9 out of the 10 companies that did this evaluation answered yes. In fact, there were only 3 entries out of the 17 that garnered this highest acceptability rating. No entry garnered 10 out of 10. So the fact that it has one of the top 3 entries for acceptability again gives us confidence that this new or potential release will satisfy the Central and Latin American markets. Coming to the third potential or the third variety or breeding line I'm about to discuss, this time it's a potential Clearfield release. As mentioned, we have both conventional and Clearfield breeding pipelines in our program. And this potential Clearfield release is derived from, you might have heard CL151 previously, as well as Nurex. So these are some of the parents of this cross. It has some blast resistance, early heading, and short and very high yield as well. If you can look at this data here, again, coming from 21 trials for 3 years. It's a 3-year average. Looking at some of the popular Clearfield releases, CL153, 163, and 151, I'm sorry. This line outperforms all of those 3 release varieties in terms of yield. So again, confidence in the fact that this will satisfy some of the producer traits that are needed by our growers in Mississippi. Now coming to the end user traits, talking about milling yield, again using 3-year data, 21 trials or 21 experiments, you have 57% for whole milled rice percentage and 69.4 for total milled rice. For grain traits, this seems to be in the shorter side of things with 6.48 millimeters average and grain length width ratio of 2.85. But one of the striking things of this potential release is also that it has a low chalk, about 7%, primarily using wind siddle measurements, and a whiteness score of 41.6. So another striking trait for 4197 is the fact that it has the Chenier type cereal chemistry. It has a high amylose, but the gelatinization temperature is intermediate, and the pasting property or RVA profile is considered as weak, which makes it similar, like I mentioned, to Chenier. So what that, in terms of the cooking characteristic, what that means is it's softer when cooked. And this has a great potential for Central and Latin American markets that prefer this type of high amylose rice with softer cooking quality. So the other, like mentioned earlier, as I mentioned earlier, in the same test that was done earlier this year, this line, 8 out of the 10 rice mills actually considered this as acceptable for their purpose in terms of grain quality criteria. And it was one of only 6 entries out of the 17 tested with 80% or higher acceptability rating from all the 10 rice mills. So again, giving us confidence that this Clearfield potential release will satisfy the end users and target markets for this type of rice. So where are the lines and the varieties that I mentioned right now in terms of seed availability? THAD is already in commercial production, and certified seeds are already with our seed companies in Mississippi. For 4193, breeder seed production is being done presently. We will harvest in a few weeks, and foundation seed will be produced by the university next year. So certified seed production by seed companies in 2022 and availability to farmers in 2023. In terms of the Clearfield, potential Clearfield release 4197, we gave some breeder seed to Horizon Ag in 2019, and it is currently being pilot tested by industry as we speak. Certified seed production, if industry finds it acceptable, will occur in 2021, and availability on a limited basis to farmers will happen in 2022. So just for, I personally am a rice eating person, and I usually buy some of the world-class varieties for eating, at least from the region where I come from. So I cook them all using a 1:1.5 rice to water ratio, and you can see the results. Very comparable to one of the most global standard for grain quality, jasmine, both in terms of raw and cooked type, whiter, all three of them. So I think we are confident in the quality of these rices, both in terms of raw and milled forms. And just to provide a summary, yes, Mississippi has been addressing quality issues to be able to deliver varieties that will fit the requirements of target markets, in this case, primarily Latin and Central America and the Caribbean. And right now, we already have THAD in commercial production. In the next two, three years, we'll have 2 new varieties, high quality, high grain quality varieties, one conventional and another one potentially a potential Clearfield release that will satisfy the markets targeted by our breeding program. So with that, go dogs.
Pues muchas gracias, Dr. Redoña. Gracias.
Thank you so much, Dr. Redoña, for your contributions to this symposium. And since we need to keep the schedule according to the agenda, we are going to go directly on to the next speaker. But if you do have more questions, please write them down in the box for questions and answers so that we can answer them later. And we are also going to have the USA Rice team answering your questions. So now we're going to have Dr. Stanley Samonte. Dr. Samonte is an associate professor at Texas A&M AgriLife Research Center at Beaumont, Texas. He is currently handling both the hybrid and inbred long grain rice varietal breeding. Before joining Texas A&M AgriLife Research in 2017, he was the breeder for premium quality short and medium grain at the Rice Experiment Station of California Cooperative Rice Research Foundation at Biggs, California. So go ahead, Dr. Samonte. Thank you for being here with us.
Okay, good morning. Buenos dias. Let me share my slideshow. Okay, good morning. I'm Stanley Omar Samonte, and I'll be talking to you about rice varietal development in Texas A&M AgriLife Research at Beaumont. So this presentation focuses mainly on the grain quality of our top 3 lines. One is our standard variety called Presidio. One is a planned varietal release, and another is an elite line. Okay. So at Texas A&M AgriLife Research, I have been the hybrid rice breeder since 2017, and also the inbred rice breeder as a team with Dr. Tabien in 2019. He retired in 2020, and I took over the inbred rice breeding program as well. Now, before coming to Texas, I was a rice breeder at the California Rice Experiment Station from 2012 up to 2017, where I bred for several grain types, which were like the premium quality short grain rice, the premium quality medium grain rice, the conventional short grain rice, low amylose rice, waxy rice, and also arboreal type of rice. Okay, this is the video of the Texas A&M AgriLife Research Center at Beaumont. It is located at Southeast Texas. So the center of Beaumont and its satellite station, which is located at Eagle Lake, houses about 40 scientists, research and administrative support staff, and also students. Research expertise in our center include rice breeding, plant physiology, soil and plant nutrition, insect and weed, and disease management, integrated cropping systems management, and crop systems modeling. So our facilities include about 960 acres of land that is in Beaumont and about 114 acres of land in Eagle Lake, which is located about 1 hour west of Houston. So our center was established 111 years ago. That was in 1909. Okay. Grain quality is one of the major breeding goals of our inbred rice breeding program. So the video that you are seeing right now includes the plots from which the rice samples are harvested for grain quality evaluation. This grain quality nursery is replicated 2 times. So the rice samples are harvested about 30 to 35 days after heading, and that is when the moisture concentration is about 18 to 21%. So they are threshed, they are cleaned, they are dehulled, and they are milled, in this case using our pass mill here. And in addition to grain quality, we develop promising inbred lines that have high and stable grain yield, blast resistance, cold tolerance, and from these we select new varieties that will be for varietal release. So this table shows the standard rice varieties in Texas when it comes to grain quality. Its name is Presidio. So Presidio is grown in about 12% of the Texas rice acreage, which is about 180,000 acres. Presidio was released in 2005, and up to now, it is a major inbred rice variety grown in Texas. Again, it's about 12% in the acreage. The next column shows Trinity. Trinity is planned for varietal release. It is now in the seed increase stage. And a third one is RU190340. I'll just call it as RU3140. Okay, it is the latest line, and we are evaluating it for potential varietal release. Okay, these are the results from the 2020 Uniform Rice Regional Nursery test that was conducted in Beaumont in 2020. So the data shows that Trinity, having a grain yield of about 1,000 kilograms per hectare, and RU3140 have about a 12% higher grain yield than Presidio. But Presidio, as we know, heads earlier than both these lines, and it is planted also as a ratoon crop. So in order to get the grain yield, the total grain yield, it is the main crop plus the ratoon crop. So that gives it a higher yield. But also Trinity and RU3140 have the potential to be ratoon. So in the end, the grain yields of Trinity is about 12 or 13% higher than Presidio. So it reaches around 12,000 kilograms per hectare. This year, the head rice percentage of Trinity was higher than, Presidio, I mean, was 61%, which was higher than both Trinity and RU3140. But in previous years, these values have been higher. For example, it has been 63 for Presidio, 63% for Presidio in terms of head rice, and also 62% for Trinity. Now, this video shows our grain quality evaluation using an S21 grain analyzer. So this grain analyzer was made in Brazil, and using this machine, we evaluate about 50 grams of whole milled rice. So this 50 grams contains about 1,500 grains. So we evaluate them according to length width ratio, whiteness, vitreousness or translucency or how clear the rice is, and chalky grain percentage. For chalky grain percentage, a rice grain is considered as chalky if at least 50% of its area is chalky, or at least 50 chalky area is seen in this grain. So the slide that the video that you showed saw earlier is the S21 in action. So it's conducted for all our elite lines that are tested in yield trials. Okay. Before I show you the results from the S21, on top are pictures of the whole milled rice. Again, this is Presidio, this is Trinity, and this is RU3140. Okay. The lengths range from 6.09 up to 6.29, with Presidio in the middle of the three. Okay. Also shown is their standard deviation in millimeters. So it ranges from 0.53 to 0.58, plus or minus 0.53 to 0.58 millimeters. So it's relatively low and stable. With regards to width, the width of these three rice lines range from 1.87 to 1.9, with Presidio at 1.88. And with regards to the length width ratio, okay, they are all higher than 3, ranging from 3.28 up to 3.34. So they are the typical long grain varieties that we grow in Texas. In terms of whiteness, using the S21, a higher value would indicate that the rice is higher. And from this, it shows that Presidio is slightly less white than Trinity, but whiter than RU3140. With regards to vitreousness, using the S21 or translucency, the higher the value, that means the more clear or transparent the rice grain is. So it shows that Presidio is less translucent or less clear than Trinity and RU3140. So the highest in terms of vitreousness was the new line called RU3140. Now for chalky grain here, I showed two values. The one on top is from the 2020 and the one below is 2019. So chalky grain percentages was high in 2020. 5.4 for both Presidio and Trinity, and for RU3140, it's 2.98. But the chalky grain in previous years have been lower. For example, in Presidio, it was 2.1% in 2019, and for Trinity, it was 1.9 in 2019. By the way, for Trinity, we have also a trial where it showed a very low chalky grain percentage, as low as 0.12%. Okay, we also evaluate our rice using a CAT near-infrared grain composition analyzer. This is shown in the video on the left. Right? It's made in Japan, And again, we evaluate the whole milled rice. So what we get out of this evaluation are reference values for protein concentration and amylose concentration. So these are reference values. It is not the concentration that you would get from a colorimetric method. So this measures the light that is transmitted, the near infrared light that is transmitted through the rice grain sample. Okay. So these are the results of the NIR grain analyzer. Protein concentrations are low. The lowest was Trinity, 6.0, and Presidio and RU3140 was 6.2. And as you know, low protein concentration values are correlated with a more tasty or more delicious rice. With regards to amylose reference values, the NIR resulted in this 15.6, for Presidio 15.9, for Trinity slightly higher and slightly lower for RU3140. Now, based on data from previous years that we have, the actual amylose concentrations are 21% for Presidio and 22% for Trinity. So these are actually within the intermediate amylose concentration or intermediate amylose category for rice. Now, the NIR also provides a quality evaluation based on moisture concentration and protein concentration. And lines that have scores of 75 or around 75 would be good rice lines in terms of taste or quality evaluation. So we have Presidio 75, Trinity 76, and RU3140 as 34. So this would be expected to taste good. Okay, now these are, we did a cooking test, and this is Presidio in a pot, about 200 grams. This is Trinity and RU3140. And this is what they look like when cooked for Presidio, Trinity, and RU3140. In terms of whiteness, they are very similar. It's difficult to distinguish one from another in terms of visually looking at it. All three are not aromatic, meaning they are not jasmine, they are not basmati, they are conventional long grain rice. The alkali digestive ratings scored were 4, 4, and 5, making them in the intermediate classification for alkali digestion or alkali spreading value. And from these results, we estimate that their gelatinization temperatures are all of them are in the intermediate category. So we conducted a small taste test in our breeding laboratory, and although all of these were good in terms of taste, the preference for actually all of us was the RU3140. Okay, so again, this is my presentation. It focuses on the grain quality of 3 of the lines, important lines that we have in Texas. I'd be glad to answer any of your questions. Thank you. And if you have if you want to contact me, you can email me at below here, stanleysamonte@ag.tamu.edu. Okay, thank you.
Muchas gracias, Dr. Samonte. Gracias.
Thank you very much, Dr. Samonte. Thank you for your presentation. And we have a question here.
How do you work with farmers as you're developing these new varieties? Do you work with millers and or exporters as well?
In developing these varieties, we work with the Texas Rice Improvement Association. If we have a elite line, then we request if they could grow it in their field and then ask them or survey what they would comment about the rice yield and also the grain quality. with farmers, we meet with the Texas Rice Research Foundation Board, and they tell us what are the important traits or qualities that they like in varieties. And with regards to grain quality also, as Dr. Redonia mentioned, there was a rice survey on grain quality, and we participated also in that survey. And Trinity was actually rated very well too. So when the question was asked, would it be accepted or acceptable in the market, the answer was a majority of yes.
Excelente, muchas gracias. Otra pregunta que tenemos es,
Excellent, thank you very much. We have another question.
seen in rice production over the last decade?
I did not get the question.
I'm sorry. Can you hear me?
Yes, I did not hear the
No
question.
problem. I'll repeat it. What's the biggest change you've seen in rice production over the last decade?
Over the last decade, in terms of, let's say, varieties, there is an increase in hybrid rice varieties in terms of acreage in Texas. That is one. Another is the decreasing acreage of rice in Texas. That's two. Third is the increase in the focus on grain quality that will satisfy the demands for rice from countries that we import. In fact, we are conducting a study that analyzes the rice that the rice of countries that we export to. So we would like to know what are the qualities that they desire. And once we verify and validate the qualities, then it also helps us in pointing our breeding towards that. So those are what I've seen in terms of breeding. Also, the varieties are getting bigger, because bigger in terms of size. The bigger the plant, the more mass there is to produce higher yield. So it's not just quality, but also grain yield as well. So grain yield, quality, and then the acreage, and then hybrids.
Excelente, muchas gracias. Otra pregunta. Do you know
Thank you very
why
much. And one more question.
but not in the rest of the United States?
Can you repeat the question? Because I was...
Of course. Do you know why we hear about smut in Texas, but not in the rest of the United States?
Very good question. That has to do with the causal organism. So it's good that the other places in the United States do not have smut, but that is a problem that we are addressing. It's the causal organism.
Gracias. Otra pregunta. The new varieties
Thank you. One more question.
Do you see a problem with lodging? And are you providing data for in applications?
Yes, the new varieties are taller, about 5 or 6 inches taller. Okay. But when we breed or select, okay, we try to remove those that would lodge. For example, Trinity would not lodge, even though it yields about 12% higher than Presidio. And we have a soil scientist in our center, and we will work closely with him. His name is Dr. Fugendo, so that we can determine the optimum fertilization management that will be applied to the varieties that we release.
Thank you for that. Next question is, what is the disease resistance package for these varieties? And what susceptibility to major diseases are a problem?
What's the second part of the question?
Of course, let me go back to it. What susceptibility to major diseases are a problem? So I'll read the whole question again.
Okay, I got it.
Okay, perfect.
Okay, our goal is to breed blast resistance into rice. Blast is a major disease here. Actually, Presidio has the blast resistant gene called PIZ. It's already incorporated into it. Trinity does not. So before we release, of course, when we release, there should be a technology package indicating that there is a need to control a blast or watch out for blast in this disease, in this rice variety.
Thank you. Muchas gracias, doctor, por sus aportes. Ahora vamos a la encuesta número 2.
Thank you, Doctor, for your contributions. Moving on now to the second survey. To have a little fun, you'll find survey number 2 now. Please answer according to your knowledge. I'll give you a bit of time to answer. And let's see the results. And in the meantime, please remember that in addition to these survey questions, whatever questions you pose in the Q&A will be answered at the end of the session. We have time for that, so please do not worry. I'll give you a bit longer. Here you have the question.
Bueno, 5, 4, 3, 2, 1. Muy bien. Y bueno, parece que.
And here we go. It would appear that absence of chalk is the most important characteristic for your consumers. Well noted. Thank you very much for your opinion. Following with the agenda, our last speaker in the first session is Dr. Kent McKenzie. Dr. McKenzie is a plant breeder at the Rice Research Center in California. He obtained his PhD in genetics studying rice. Both his degrees come from the University of California, Davis. He has participated in the development and launch of a number of rice varieties and patents. Thank you for joining us, Dr. McKenzie. The floor is yours. We're all ears.
Buenos días. Well, thank you for allowing us to participate here to USA Rice and you individuals listening outside of California. I have a presentation here on long grain rice varieties from California. This is the work being done at the Rice Experiment Station in Biggs, California. You're seeing a picture there of the facility from above. Next slide. The Rice Experiment Station is owned by the California Cooperative Rice Research Foundation. This is a grower-owned foundation and is a nonprofit foundation. The Rice Experiment Station was established in 1912 and is the research and seed production facility. We have 17 full-time staff members, 6 PhDs, including 3 plant breeders. We are overseen by an 11-member board of directors who are all rice farmers. The rice breeding program is primarily funded by the California Rice Research Board through a grower assessment and checkoff funds. So I and my staff work for the growers directly. This is different than your other programs in the public sector where they are university employees. However, we do operate in cooperation with the University of California, primarily UC Davis, and also with the USDA here in the US, that's the Agricultural Research Service. And of course, our link to USA Rice is the California Rice Commission. The primary mission is to develop improved rice varieties for California and their production and maintenance of the foundation seed for California. Our varieties are not grown in the southern Delta US. They're not adapted for that location. California rice varieties from CCRF are grown on about 90% of California's rice acreage. And the varieties are grown exclusively here, and they are protected under plant variety protection and utility patents. California rice production does vary a little bit from the southern US, which is not mentioned on the slide. We primarily water seed our rice as opposed to drill seeding that was pointed out earlier by our speakers. Water seeding, the seed is pre-soaked and the fields are flooded after fertilization, and the rice that is pre-soaked and germinating is flown into the field, and this has been our production system pretty much since the beginning. The reason for that is it provides very effective weed control for grasses. Next slide. So California grows mostly temperate Japonica medium grain rice. You may recognize the cow rose market type, which is grown worldwide. The accelerated breeding program here was started in 1969 through the checkoff program I just mentioned, and has released 50 new cultivars and involves 10 different market types. As part of that diverse portfolio, developing adaptive long grain rice for California with seedling vigor because of our water seeded system and reproductive cold tolerance, as well as good grain quality, have been a major component of the rice breeding program for the past 50 years. In the bottom of the slide, you'll see the different varieties produced by the Rice Experiment Station. You'll see the medium grains, and the variety names are not very glamorous. M tells you it's a medium grain, and the numbers relate to the maturity group and the release number. Example, M105 is a very early medium grain, and it is the 5th release. In the short grain market, you'll see there's S's for short grains, conventional, and then you'll also see the Calicari, which are the premium Japanese type. And then for special purposes, we have waxy mochi or sweet rice. Those have a Japanese version of a name, Cow Mochi 101. And we also grow a low amylose rice called Cal Amylo. But here today we're to talk about our long grains, and they're traditional US long grains. The varieties are L207 and L208. And then we have some aromatics as well. Next slide. So of the varieties in production right now, we have L206, which was our standard long grain, and actually it is now being replaced with others there. On the right hand, top of the slide, you can see the different grains in comparison as well. The second variety released more recently in 2016 is L207. It has a yield advantage over L206 and a larger kernel size over L206, and that is why seed production of L206 has ceased. Related to L207 is L208, which was just released in the past year. We will be sending seed out to seed growers in there as well. It's very close related. It has earlier maturity. It is shorter than height, should help us with lodging resistance. And again, it has another yield advantage over L207. Next slide. So the breeders who've been involved in the program are Dr. Farman Jadari. Farman has retired, but these varieties have come out of his program. And Farman had worked at the experiment station and previously worked at LSU, as I had as well. Virgilio Ndaya is our director of plant breeding, and with Farman's retirement, he has moved these varieties forward through our foundation seed production. On the slide, you'll see the results of several years of testing with the amylose content values listed for the different varieties in comparison in the third column, and the protein values for brown rice or white rice listed there as well, with the averages at the bottom. You can see these are intermediate amylose types, longer amylose types. They have intermediate gelatinization temperature, typical of US long grains. In the figure below, it shows you the results of the rapid viscoanalyzer breakdowns for the different varieties collected on those same samples as well. On the right are some examples to show the kernel size and translucency. Next slide. We also grow some aromatic long grains in California. These have a different designation. A is for aromatic. A202, shown in the slide, was released in California to seed growers in 2014. It replaced an older aromatic that was later maturing, known as A301. This is a conventional aromatic type, conventional US long grain, but has the aroma there as well. Also on the slide, it shows Calaroma 201. This was released to growers in 2018. It is our first jasmine type rice for the California market. Below, you'll see the length and width ratios for the varieties. L206 is just included as a comparison. It is not an aromatic variety. So as you see the columns there, you can see the patty rice lengths and widths, the brown rice lengths and widths, and the length width ratios are included, as well as the 1,000 seed weight. Next slide. So this slide shows you some of the analysis for the amylose and protein content of those aromatic varieties I mentioned, again in comparison with L206. Which is not aromatic. And notably, you'll notice that the Calaroma in the top right figure has a lower amylose content, which is typical of the jasmine quality there as well, and also has a lower gelatinization temperature, which makes it cook soft and sticky, which is characteristic of the imported Thai jasmine there as well. You see some pictures on the left of the varieties in the field, these two aromatics. And I just wanted to point out for the Calaroma that there was some work done by some researchers at the University of Arkansas, Mills and Wang, for kernel dimensions, kernel colors, chemical composition, pasting, cooking, and aroma. And it placed Calaroma 201 in the same cluster as imported Golden Phoenix and Three Ladies Homali rice, which are major imports and commercially available here in California. So we are pretty pleased with our first effort to try to develop a long grain jasmine rice for California there as well. On the right end of the screen, again, you will see the RVA profiles for L206, A202, and Caloroma 201. And again, you might recognize that, of course, the Caloroma has a much weaker profile as characteristic of its cooking qualities. Next slide. So there are some considerations I wanted to point out for any interest in California rice. Although we are part of USA Rice, our rice is grown in a different environment under a different production system, and the genetics are somewhat different than those in the breeding programs in the Mid-South and Delta. It is a more temperate climate as well, and as we know, rice behaves differently when grown in different climates. I think Dr. Famoso pointed this out as well. The long grains produce yields equal to or higher than other California types, including our medium grains. Often the long grains will out-yield our medium grains, and we do get commercial yields above 11 metric tons per hectare, so they can be quite productive. California has relatively few rice diseases and insect pests to impact grain quality, but California production and processing costs are high. It's expensive to do things in California. I've lived in the South, and it's not as expensive to do things there, I'm sorry, but that's our reality out here. And finally, currently there's only a small production. This is less than 3% of our 550,000 acres of rice. There are just a few small mills and marketers that are handling the long grains, and they typically do it under contract with growers. I will add that a number of the long grain growers and production is in the organic market as well, which is present in California and especially in the long grain rice. So I've added here for more information on the marketers and mills in California, the website for the California Rice Commission, and of course the Rice Commission is our link and a member of USA Rice. Next slide. So we have opportunities for questions. I want to point out, I think it was mentioned that I will be retiring shortly from this position. Dr. Russell Rasmussen is the new CEO. Boots Ndaya is our Director of Plant Breeding. Shamal Tadlukner is a breeder and will be focusing on long grains. Dr. De Leon is our premium short grain breeder, also brings us some other technical skills. And finally, Dr. Cynthia Ndaya runs our DNA lab. Yes, we do marker work for our quality. We have many of the machines you have seen elsewhere in the presentations, and we do not have GMO rice, and gene editing is not part of our breeding variety development program at this point. So that's it, Asia.
Excelente. Muchas gracias, Dr. McKenzie.
Excellent. Thank you so much, Dr. McKenzie, for your presentation. And we're going to continue with some questions. First of all,
is rice acres in the US or in California specifically decreasing, increasing, or staying the same over time?
The acreage in California is operating, droughts or not, around 500,000 acres. I think it may go down a little bit, but and we're always subject to water controls. But I think the rice producing areas in Northern California are very adapted to growing rice. They're not so adapted to other crops. We've been here for 100 years. I think we'll be here longer.
Gracias. Otra pregunta. In the US, farmers can often choose between several crops. How do they decide what they will plant in any given year?
Well, unlike other places, California's rice is grown consecutively Most growers plant rice after rice. That's one of our challenges here in terms of weed control. Some rice may rotate into some vegetable crops, possibly tomatoes, maybe sunflowers, but those are on at least so far have been in the certain regions of the state. Some rice fields have gone into trees, walnuts and almonds. Obviously, those aren't going to be rotated back in very quickly, if at all, on that as well. So California production system is primarily rice after rice. So the people that are in rice stay in rice.
Great, thank you. And can you just talk a little bit about smut? It says California is emphasizing smut now, and it's an emerging problem. Can you give us your thoughts on that?
Yes, kernel smut has been present in California for a number of years. It's a very ephemeral problem. It's hard to know when it's going to show up and when it's going to go away. Typically, our experience is that long grain varieties are much more susceptible to kernel smut than our medium grains. The university is doing research on that. There are fungicides with the propiconazole basis that seem to be our best tool, also used elsewhere, to try to control the disease.
Excellent. Thank you for that. Another question that we have is, would you please repeat the meaning of S102?
Yes. Okay, the variety naming system in California has a letter at the beginning that gives you the grain type. M would be medium grain, S would be short grain, the L would be long grain, and then the specialty varieties might be A for aromatic, which are long grains at this point, or Cal Aroma for the jasmine type, or Cal Hikari for the Japanese type. The first number indicates the maturity group. So a 100 is considered a very early variety. A 400 would be a late variety. And then the next two digits are for the release number. So S102 would be a short grain. It's very early and it's the second release. Okay, M401 would be a medium grain, a late maturing variety, and the first release. Not very glamorous like the lovely names they have in other countries for their varieties.
Gracias, thank you for that. Another question that we have for you is, in your opinion, which rice does Japanese type food restaurants prefer? Calrose or short grain varieties?
Yeah, typically California is very focused on the Japanese market. As most people are aware, most of the, at least in the US, all the sushi rice is basically Calrose. This would be a medium grain type, softer cooking there as well. The Japanese have higher premium quality rices for their table rice, which make fine sushi, and those would be the based on what we call the koshikari ancestry, and that would be our regular our specialty short grains, which follow the Calicari trademark or naming system, I should say.
Excelente. Another question for you. Variety and grain type diversity has its advantages, but also has problems with identity preservation. Is it practical to grow many types of rice in California?
Okay. So most of the rice grown in California is Calrose. And frankly, most have all been varieties developed by the Rice Experiment Station. So as the varieties are released, they're very similar in their grain qualities. Individually, we could see difference, but as a commingled product, that is Calrose. That's what you'll find in the marketplace. And from the production end and from the handling, all our Calrose goes into one mix, if you will. The long grains and the specialty things, those are different types, and usually those are identity preserved. You have a long grain producer or a premium short grain producer, and they will keep those varieties separate. So yes, in California, we've been fortunate in that all our medium grains are coming out of the same genetic pool, so they're very similar, so they are commingled, which is effective in terms of delivering the rice to the mills and handling it and processing large amounts of rice. But the specialty rices have been identity preserved and kept separate for processing and marketing.
Thank you for that. One more question that we have for you, Dr. McKenzie, is what is the single major advancement we should look for to come out of California rice?
Well, my retirement? No, that was a joke.
Good joke.
I think we are looking at trying to make the next jump in yield. We were probably the first to get into semi-dwarfs here, at least in the US. That was a big improvement. It took us a while to do that. So I'm thinking it's going to be just a lot of hard work to be able to move our yields up, because they get harder to move up, and to use whatever technology we can make available and is acceptable to try to get that next increment of yield and carry the quality with it.
All right, one last question for you, Dr. McKenzie. Thank you so much. What market, i.e. country, is California focusing its long grain rice production?
Bringing long grains to California was a challenge first, because long grains typically were not adapted to our cool climate. So they've worked for 40 years to do that. Our market quality parameters have been US long grain rice. This goes all the way back to my PhD, if I can talk about history a little bit. And so I think with a lot of work, they achieved those. Some of our varieties have been used, especially in Louisiana, maybe a little in Arkansas, as parentage for some characteristics. So we haven't focused, we've only focused on trying to get to that point as a comparable US long grain. The market has changed, and if it would have been frankly easier if we had been able to focus in some ways on some of the Latin American types, because some of the quality parameters we had to focus on were a little harder here to meet the US quality. Example, the New Rex type that was mentioned earlier. We have a New Rex variety, it was released, looks very good, but essentially there was no market for it, at least here in California. So I think we'll have long grains as part of our program as demand for quality types might shift or change. We will add that to our breeding program.
Excelente, muchas gracias. Thank you, Dr.
Excellent, thank you very much. Thank you, Dr. McKenzie. Well, ladies and gentlemen, thank you for your attention. We have ended session number 1 of the US Rice Quality Symposium. Now we have a brief pause, 30 minutes to rest and have lunch, whatever. And again, I want to thank you. I want to thank all the speakers from session number 1. And so in 30 minutes, we're going to continue with more useful information from the speakers for session number 2. Please be punctual so we can start on time the second session. Well, thank you very, very much. Okay, see you in 30 minutes. Have a good lunch.
Hola, bienvenidos nuevamente a la sesión número 2.
Hello, and welcome again to the second session of the Rice Quality Symposium. So far, we have received information from our 5 panelists and specialists, and in the second session, we will hear from 4 additional specialists who will be sharing with us their knowledge and experience. Before we begin, we have one more question. We're going to ask you to answer another survey question, question number 3, which is, for those who speak English, I'm going to read the question aloud so you can hear the question.
Element most influences your consumers' rice purchases? Would it be price, quality, brand, or a global pandemic? One more time. Which element influences more which element most influences your consumers' rice purchases? Price, quality, brand, or a global pandemic? Por favor, responderé de acuerdo con su conocimiento y les doy unos momentos.
Please answer according to your knowledge and experience. I'll give you a moment, and in a moment we'll see the results.
A ver. Bueno, los resultados.
Here we go. The results indicate that price is the most influential factor when it comes to consumer purchases of rice. Very interested and duly noted. Thank you very much for your responses. And now we're going to begin our second session with Randy Utz and Dr. Kiming Xiao's presentation. Kiming Xiao is in charge of U.S. rice at Nutrien and Solutions. He has a lifetime of experience in agriculture, focused largely on seeds, the characteristics of grain, and pesticides. His colleague, that was for Randy Utz. Dr. Kiming Xiao also works at Nutrien Ag Solutions. At the Rice Research Center, he obtained his doctorate in 2003 at the Louisiana State University. Prior to that, he worked in China as a rice breeder and university professor. In 2015, he joined Nutrien, where he directs the program for developing inbred and hybrid varieties. Welcome, doctors. The floor is yours.
So thank you to everyone, and I want to make sure, Aisha, are we set up correctly? Everything ready to go?
You are ready.
Perfect. Thank you so much.
Adelante. Muchas gracias.
Gracias. So thank you very much, and I'm sure there's a lot of people looking that I've probably met over the years or actually know, and welcome. I wanted to thank the USA Rice Federation for sponsoring this in light of us not being able to get together personally. I think this has been a very good session so far. I want to show you what Nutrien is doing and what Dr. Kiming Xiao and I are doing with our rice program. So with that, in 2015, I joined Nutrien, came from Horizon Ag, where I was there for almost 12 years, and we purchased Bayer Crop Sciences hybrid rice program located in El Campo, Texas. So our staff there, as you can see, we're a small program. We're a really big company, and Nutrien is the largest agricultural retailer in the world. So we have extensive seed interest all over the world, especially here in the United States and growing in Brazil and South America. We sell cottonseed, corn seed, soybeans, wheat, sunflower, just about every major row crop in the United States. We have a presence in that market. For rice seed, as a retailer, we currently sell about 30% of all seed that growers buy in the southern United States. So we have a very good understanding of rice. We know what growers like. We on a daily basis, we understand what's working and what's not. And we're using that information for our own breeding program to try to develop things that fit the market. And it also sets the tone for how we screen, what we look for, what we don't pursue once we understand things in the market. So We have a state-of-the-art research station. It's very well capitalized. We lack for nothing really, but a small program. But we're making giant strides, and I'll show you how. So next slide. So what do you look for? Our breeding priorities would be the same as most any other program. I think you've seen the technical things that other programs are doing with Dr. Shah, Dr. Famosa, others. We're no different. I didn't include a lot of that in this presentation, but we're doing the same things. And point number one, we look for yield and quality, and in addition to that, disease-resistant traits, and also storm tolerance lodging. I've heard several questions today about lodging, and that is a big component of our program. So what we're trying to do is develop varieties. In addition to our hybrid program, we're looking for varieties that might approach hybrid yields and with quality. And we're able to do that not only with our own DNA work in our lab in Saskatoon, Canada, where we test DNA samples to advance our program. We also work with LSU and other partners to work in this area of our program. We're still trying to develop 3-line hybrids. We think 3-line hybrids ultimately in the future are the way to go. And it's more difficult, but I think we'll get there, and we'll have some very good hybrid material. We work primarily in long and medium grain rice. We look very closely at amylose and gel temp. We understand the relationship between those 2 points as well as anyone. And I've had a long career working with Central Americans and understanding the South American market, and listening to Dr. Linscomb and others that know it better than I, but we think we're onto some things that would help the industry. And the last point is ultimately in hybrids, we understand pubescence and chalk in the current hybrids, and we think that we've figured out a way to eliminate that, and that's one of our goals. So our program is just as technical and just as complicated as anyone else, but we're making great strides. So next slide. So talking about chalk and looking at a typical U.S. variety, that's probably one of Dr. Linscomb's pictures I borrowed, but we understand chalk. He gave a good explanation of where it's coming from. We talk to millers, we talk to downstream customers about what they like and what they don't like. So we understand this, and it's not focusing on anything good or bad. It's just what we know is happening in the marketplace. So we're well versed in it, and we think we're finding answers. So next slide. So if you look at this particular slide, this is our first release that will be launched next year is DG263L. The DG is for our brand Dynagrow, the number 263 from our breeding program, and then L for long grain. We look at things, wind seedle and other ways all the time, and compare our stuff in the lab to what's out there. And you use competitors for yield and disease tolerance and other things that you want to evaluate your own material against. So quality is always something that we're looking at. This first release, and you'll hear a little more, is very exciting, not only for us, but for growers and also for millers. So next slide. So we took a decision in 2019. That's our station in El Campo, Texas, which is south of Houston by 1 hour. And we made a decision looking at this line, especially due to the lodging attributes, because in 3 years, we've had 3 hurricanes come to our station, and this material stood remarkably well each year. So on top of that, we were seeing yields that were 9,000 pounds or better even after hurricanes, which was very surprising. So we bulked the lines that Dr. Chow was working on, and next slide. We worked at the University of Puerto Rico, just like most people do. It's the best place, in my opinion, for winter increases for what we need to do here in the United States. And we also have Dr. Linscomb, who's been a huge help to our program. Dr. Linscomb has been consulting with us for the last 3 years. He understands our program. I couldn't ask for better help. We also work with specialized seedsmen, and Mr. Zach Tanner from Missouri, who's on the right in the blue shirt, probably one of the best seedsmen that I've ever encountered. So in order to bring pure lines to market, they have to be pure, and we're focused heavily in that, of eliminating off types, eliminating things that contribute sometimes to quality problems. So next slide. So in looking at a variety, growers will grow anything you ask them to, but growers expect yield first. And that's been some of the problem with high quality varieties, where a grower might want to grow something, but the yields aren't there and the economics aren't there. So we started looking third party with our trial work in 2019. This is University of Arkansas, and looking at the yield in what was called DGL 263 at the time, and comparing it to some of the hybrid material. And this is the kind of yields that we've been seeing, and it's very surprising, but it's also been very consistent. And one of the problems with inbred lines is not the highs that you get, meaning really good yield. It's the lows that you get when disease hits and becomes a problem. And we don't see that with this first release. It's very stable, it's very consistent, and we have seen that for the last 4 years. So it's unique. I personally have not seen this ever. And so next slide. You don't ever go on 1 year's data, and we have 4 years data with this material, but in this year's work, this was a planting date study done by Dr. Jared Hartke, who is also favorable toward this variety. We see the same numbers. And I'm very confident, as is Dr. Shao, of what we have is special, and what not only from a yield perspective, but we're also seeing the quality that everyone would like to see. So next slide. So just a quick look at our rice seed business. Again, we sell about 35% of all the rice seed sold in the United States. We've not sold any of our own yet. With this first release, DG263L, we anticipate a launch size of about 75,000 acres this year, which is not huge, but it's a good size launch. We see our first variety picking up about 5% market share. Historically, the problem with finding high quality, high yielding varieties is people simply don't grow enough. And even when you try to contract for them and have them identity preserved, they're hard to find. So what I do hope, and what I think I know, is after this year, based on the input that we're getting now, in 2022, I would suspect that we might see 250,000 or more acres of this particular variety. And being an inbred, the seed is easily produced. So we don't know how high it goes, but we know that it's going to be very popular. So next slide. And just another look at Nutrien as a whole. Our intent as a company buying the program from Bayer was to have our own products in addition to selling our partners' products. And I feel pretty comfortable that we'll have a hybrid. Our first 3-line hybrid should enter the market 2024, 2025. Interestingly enough, some of the lines we're bringing to market as inbreds are also restorer lines for our hybrids. So the quality issue there, based on the quality of parentage to produce, we think is going to be a good selling point for us, and telling growers, you planted it as a variety, here's a hybrid version of it, and we'll maintain our standards. In our program, we don't move anything forward that has more than 10% chalk. We don't look at amylose contents. We shoot between 19 and 25. DG263L has 26% amylose, and we've also identified the Dixie Bell gene in it, showing this really high amylose, which is unusual. So we watch that. We also look at disease, and the disease package of this particular variety. It's resistant, or moderately resistant to panicle blight. We know it has a cercospora gene in it for cercospora resistance, and our blast testing and inoculated trials has shown it to be very comparable to anything hybrid or varietal seed choice out there. So I think that's where we get the yield. And smut, several questions about smut. We haven't finished rating this variety yet for smut, but we don't see it. And it's interesting, even where you have high nitrogen use and sometimes heavier seeding rates, smut being such a problem, we have not seen it in this variety. So more good news for us. So next slide. I think, and this is basically in close, some of you know me, some of you know Dr. Shao. You may not know Nutrien, but it's a very large Canadian global company, publicly traded. And we've got the assets that we need to keep building our rice program, which is our intent, and try to bring new and novel products to the market for not only the U.S. growers, but for the U.S. export market. And we understand, we know what the export problems are, and we think that we found some things that's going to help alleviate a lot of that. And it's just a matter of bringing good products, being open and transparent, and trying to help people find what they want. So that's all I have. And the last slide, our contact information, myself and Dr. Shao. If we can help you in any way, please reach out to us. Be glad to help. And thank you.
Bueno, muchas gracias. Le damos las gracias a sus aportes en este tema.
Well, thank you very, very much. I want to thank Dr. Utz and Dr. Shao for your contributions. And following that, we have some questions here.
How long do varieties typically stay in rotation in the United States?
So the question is, how long do varieties typically stay in rotation?
Correct.
You know, it varies. I've seen some in my former career that lasted 1 year. I know of some still being planted now that are maybe 20 years old. So it really depends on what growers are looking for and what space that it fills. So you don't like having a one-hit wonder, as we say, but sometimes that happens. A lot of times when that happens is when it just so happened that it was the wrong year to release a variety, because what we know about U.S. growers is if they have a bad experience, they typically will not try a variety again. So that's frustrating for people in this business, but it's a fact of life.
Thank you for that answer. Another question that we have is, when will you have this variety with resistance to herbicides?
Good question. We're actually working there and making some progress and looking at the market, looking at what's available today, and then coming up with something that gives you a different approach, or looking at regulatory consequences of trying to do that. But that's a good question. I don't know what the exact answer is, but hopefully sooner than later.
We will have the first year trials next year for the herbicide resistant.
Thank you for that. Another question is, are you incorporating any technology designed to target weedy rice or red rice?
Yes, we're actively working with other partners in the industry with different traits for that. We're also looking at that as a possibility. And there's several ways to go at that. Looking at the quizalofop strategy right now, which is a very good herbicide. We're also working there with some research material, but we're also looking at some alternative ways to maybe pursue that. So to be seen, but yes, we are trying.
Thank you. One more question for you. Are your varieties bred for US production or for other countries?
So at the moment, this is as much a discovery as it was a breeding effort. And as we say, sometimes being lucky is as good as being smart. We happen to have been able to do both with this particular line, but it fits the US market exceptionally well. And when you see something with such high yield potential that also has low chalk and it has such high milling, and we're seeing milling samples coming back as of today that are 6270, 6371. You're seeing mid 60s in some of this material, which is really important for growers because of premiums that they can earn at delivery. So we understand the export market. We look at things like the Nicaraguan chalk standards that are so difficult to meet. We look at everything that's going on, and what we're trying to do is assay the landscape and then develop things that are as good or better than what's in the landscape. And that's easily said, not so easily done. It takes a lot of work.
Thank you for that response. And one more we have, you talked about, there was 30%. We talked about the number 30%, but in what states?
I don't understand the question. Was that relative to the launch?
Let me see if we can get that question of seed cells, 30% of seed cells. And what?
Oh, I'm sorry. Our retail seed sales.
Mm-hmm.
We sell seed in 6 states. So, of course, Arkansas being the largest, Missouri, Tennessee, Mississippi, Texas, and possibly a little in Illinois. So only the southern rice belt. We have a significant business in California, but we don't sell rice seed there.
Excellent, thank you. And another question that just came in is, with the changes in climate, have you thought about using other varieties that we've used in the past, which have a better resistance to the actual climate?
Not so much. You know, that's an interesting topic for people. And we look at novel germplasm. We look at what it brings to the market. Looking at hybrids and effects on greenhouse gases and the future of things from a stewardship perspective. Nutrien has a very robust stewardship division, and we're looking at that to coincide with our rice development. We're the largest nitrogen and potash manufacturer in the world, so you owe it to your customer base if you can help understand that piece of agriculture to put that forward, and we're doing that. So older lines, I'll tell you something about this variety, the DG263L. It looks like the old Lamont variety of old to me from a height perspective and the way it's harvested and all that. So you can go back and look through old stuff. Doesn't mean it might not work, but generally what we're doing is to work with newer lines, newer breeding techniques, and to make crosses there.
Thank you so much. Ahora Vamos a continuar las
We are going
preguntas.
to continue now with the questions, or pardon, the questions that we haven't answered yet. We will be moving them to the end of the day where we will have more space. Thank you, Dr. Oates, for your contributions. Following now, with the day's agenda, we will be hearing from the specialist, Dr. Tim Walker. Dr. Walker, in 2014, became the CEO of Horizon Ag. Before incorporating, Dr. Walker had a long career in rice development in the Mississippi State University. In addition, I have the great honor of having worked with Dr. Walker in his capacity of leader of the Subcommittee of International Promotion for USA Rice. He was selected in July of this year to take on this role. Our congratulations in your new role, Dr. Walker, and thank you for being with us. Welcome. The floor is yours.
Bienvenido.
Thank you, Aisha, and thank you, USA Rice, for putting this presentation on. I'm very excited to be able to share the panel. It's a very, so much of an honor to work very closely with all of the individuals that have spoken, and not just working with them, but many of these relationships go back for many, many years. Practically all that have spoken today I have known since I first entered the rice industry a little over 20 years ago. So again, it's always an honor to share a platform with these individuals, and today I think is very special because many of us have worked so diligently to hear the concerns from our Latin American customers and go about daily over the last several years to try to get us to a point where our product could be considered the gold standard once again for these markets. So just want to say thank you for the opportunity. As Aisha said, I have 22 years in the rice world, so to speak. I spent the first 16 years of my career in the university, various job titles, so to speak, from a graduate student all the way to full professor. And as I was doing research with the university, I was an agronomist. I did a lot of soil fertility work early on in my career. But the last few years, I had the great pleasure of working in a managerial role of our rice breeding program at Mississippi State, the same program that you heard from Dr. Redonia earlier this morning. And as Randy just mentioned, he had a long tenure at Horizon Ag, and so in 2014, when Randy chose to leave Horizon Ag, he and I had a lot of conversations prior to me coming on board at Horizon Ag. So I've had the great pleasure of leading Horizon Ag for 6 years now. And I think probably for many of you, you know that Horizon Ag previously under Randy's leadership, as well as under the last 6 years, we have certainly been a huge advocate for rice quality improvement. And I know, especially since I've been at the helm here at Horizon Ag, I've been a huge proponent for dialogue to better understand the Latin American wants and concerns, and then bring that knowledge back to our breeding institutions and industry as a way to try to educate them so that we can continue to maintain market share in these extremely important markets. So as I as I go forward, Horizon Ag, I think, is really, the brand has become synonymous with Clearfield rice and the newest herbicide-tolerant rice called the Previsia rice system. The Previsia rice system is still very early in its, I guess, its commercialization. We were successful in our third year of making Previsia varieties available in 2020, and I look forward to continuing to grow the availability as well as the success of this technology as we go forward. Clearfield, as many of you know, has been around for quite some time. Horizon Ag was built essentially to help steward the Clearfield technology, and we've been quite successful at doing so. And so today, you've heard from many of the researchers already talking about some of the new varieties, so I'm not going to rehash what they have already spoken of with respect to the quality traits and all of that. I will spend some time talking about a couple of varieties that we already have in the market that has been, I guess, accepted for the most part by Latin American consumers. And so I'll talk mostly about them, but then also talk about these new varieties and how they can be sourced based on territories going forward. So again, CL 111 and CL 151 are what we would consider our legacy varieties. These varieties, as Dr. Linscomb mentioned earlier this morning, are 10 to 12 years old now. And I think the question was asked earlier about how long varieties can stay out there. And as Randy mentioned earlier, it really depends on their success. A variety like CL 151, I can remember having conversations with Randy maybe as early as 2010, 2011 about the potential for discontinuing that variety. And I've, since being at Horizon, I've had that conversation multiple times about discontinuing it. However, we continue to sell CL 151 today. CL 111 is still sold as quite a bit of a percentage of our portfolio down in South Louisiana, because the variety just works there. It's not always the highest yielder, but it just works. It works within the culture of South Louisiana, and it's always going to be one of our top sellers, or at least it has been for a number of years now. So CL 153 was probably one of our best attempts, I think, at trying to address some of the quality concerns that we knew or had learned after the 2010 and 2011 landmark, so to speak, of where it really came to the forefront where there were some quality issues in the United States. CL 153 was first commercialized in 2017, but it was chosen and selected by Dr. Linscomb, and then as we work as the marketing arm for Clearfield Pure Line varieties in the Southern United States, we chose that variety because of its grain length. It was the first grain that we had in quite some time that was what we would consider truly a 7 millimeter grain length. It had very low chalk. It does have the intermediate amylose and intermediate gel temp. CL 163 is a variety that I actually selected as a breeder at Mississippi State, and it was the first Clearfield variety that was released that had the Dixie Belle cook type. So I'll talk more about those in a minute. The CLL 15, 16, and 17 are all new varieties in our portfolio. CLL 15 is a semi-dwarf high yielding variety that is most adapted for Arkansas and the rest of the upper Delta. CLL16 is a more conventional statured rice type, again, developed at the University of Arkansas. And we're quite excited about the CLL16 going forward. I know this year and in years past, it has given us what appears to be a step change in yield potential from varieties that we've released in the past. Another variety that we're very, very excited about, especially for South Louisiana and Texas, is CLL17. Again, a semi-dwarf variety with high yields and very good quality. So you'll begin to see and hear more about these varieties going forward. But as we move forward into today's conversation, I'll talk mostly about 153 and 163. So from the Previsia portfolio, again, Previsia was developed in a very, very short period of time. PVL01 was the first released. It was released in 2018. PVL02 was first available to farmers this year in 2020. And we have seed production planted right now for PVL03, which could quite possibly be available on a very limited amount in 2021, but a more widespread launch in 2022. PVL01, we chose not to go forward with that particular variety. So 2020 was the last year of seed sales to farmers for the PVL01. Sarah, I think we can go to the next slide now. So let's talk specifically about these varieties that have already had some acceptance in the Latin American market. First, CL163. You've heard the term Rexmont. You've also heard the term Dixie Belle. They essentially are one and the same. But we do have I guess, a genetic background of rice that has the higher amylose content. However, unlike most rice sourced in South America that has high amylose, it does have an intermediate gel temp. The amylose content of CL163 is about 26%. The grain length is about 6.7 millimeters. And again, you've heard some of the scientists talk about Winseedle. And so for a number of years of data, the CL163 has averaged about 10% chalk according to the Winseedle measurement. So as we talk about CL153, it is the typical southern U.S. long grain where we have an intermediate amylose and intermediate gel temp. 21% amylose content. As I said just a moment ago, it is a 7 millimeter grain length and a 6% Winseedle chalk.
Com 6% de
Next slide.
Próximo.
So looking at 3 years of head-to-head comparisons for CL153 and CL163, I also put Chenier in there as a check for reference because Chenier typically is considered a very high-quality rice in the southern United States. So as you can see from a chalk standpoint on Winseedle, CL153 are very, very similar, whereas CL163 have about a 3.5% higher chalk percentage compared to
E
the
nós
153
comparamos
and
com a
Chenier.
variedade 153 e a Chenier.
So, having had many
Então,
conversations
depois
with
de várias
many of the Latin
conversas
American friends, we
com
have
nossos
tried
colegas
to
da
better
América Latina,
understand,
nós tentamos entender
you know,
melhor
how to
como que nós
test rice,
poderíamos testar, fazer os
you know,
ensaios
with
com
respect
arroz,
to cooking. I mean, we all
em
can
relação à
begin
cocção,
to put objective numbers on chalk
porque
with the tools like
podemos pôr
Winseedle
números
and
objetivos em
others,
relação ao
but
vencimento e a outras
and I
variáveis.
try to tell this to
E eu tentei
the people that I interact with.
conversar com o pessoal com quem
I don't
eu
even know if
interajo.
we have mentioned it today.
Eu nem sei se eu
but
mencionei hoje ou se
US
mencionamos hoje.
people typically don't eat a lot of rice.
Em geral, nos Estados Unidos se
The
consome muito
number
arroz.
is
As pessoas não
probably
comem tanto
well
arroz nos
over
Estados
100
Unidos.
pounds of rice per person per year in Latin America,
Na América
especially the
Latina
Central American countries,
é muito maior o consumo do
compared
que nos
to
Estados
20 to
Unidos, quando nós
25
comparamos a
pounds in the
20
southern United
20 mil
States.
toneladas no sul dos Estados Unidos. São
You
centenas
know,
na
when
América
we're
Latina e
talking
20
about
pouco nos Estados
quality,
Unidos.
you
Quando nós
know, one of
falamos
the
da
things that I've
qualidade,
tried to
uma das coisas que eu
encourage,
tentei, na realidade,
I guess my
incentivar
circle of
até
influence is let's
no meu círculo
listen.
de
These people eat a
influência,
lot of
seria
rice.
ouvir essas pessoas que
They are
consomem
very
muito mais
much
arroz.
more in tune with the experience of rice eating than many of
tem
us who are
a
making decisions
experiência
are in the United States. So as I've had those conversations, you know, we want to further delve into, you know, how rice is graded by the end consumer. And so I know that rice that, you know, certainly we want it to appear a certain way in the package, but then what is the texture, and, you know, how does it feel on the palate of a, you know, Latin American consumer? So the thing that I hope that you saw in the video with CL163 is that, you know, it's quite loose with respect to that final cooked product. I think the next video that I will show goes in and shows, as I understand in my travels in Latin America, rice is cooked typically in the morning, but they may eat it multiple times throughout the day. So this is a video showing how rice, the looseness of it upon cooling. Sarah, I don't know if you could show that video again, and I have no idea whether it's possible for me to share it, but nonetheless, once the rice for the CL163 cools, it is quite loose. Something that I think approaches. Did we
You
lose
can go
our
ahead and share now.
screens?
Did you want to try to share your screen?
Okay, I will continue on. Aisha, I lost the.
Dr. Walker, if you would like to share the
back
video on your screen, you
Okay,
can
Sarah,
do
if you
that.
could
Oh, great.
advance the slides to CL153. So we have a little technical where the rice is to the side, but I think you can probably see the CL153 being an intermediate amylose, intermediate gel temp is just a little bit stickier than what we see with the CL163. Next slide. Likewise, when the rice cools, it is just not quite as loose as the CL163. So I definitely think, and I'm certainly curious to hear more from Raul later to talk about how they're coming and understanding the components so that we can have a rice that is more adaptable, that can be grown here in the southern United States, that has the qualities that our very important export customers desire. Next slide. So looking at 2021, varieties CL111, 153, CLL 17, and PVL02, those varieties will be the bulk of our portfolio in South Louisiana and Texas. As you move north, the CL163 is most adapted in North Louisiana, the Mississippi Delta, and South Arkansas. PVL02 will also be grown quite a bit in South Arkansas. This is largely because of a lot of the weedy rice complex that we have in South Arkansas. So our Previsia technology has been adapted more in South Louisiana, South Arkansas, and a few counties in Northeast Arkansas, the most thus far. And then the long grain varieties CLL 15, CLL 16, and PVL02 will be grown in Mississippi, Arkansas, and Missouri. And the reason I put this here is, I understand that more countries are coming to the table and trying to, number one, identify varieties that work for them, but also number two, once they identify varieties that work, how do they get them? How do they source them? And so, again, these varieties by locations, I think just gives our customers insight into, how to go about purchasing variety-specific rice for 2021. Next slide. So with that, I will be glad to answer any questions. Again, I appreciate everyone joining in today and hope that the information that we've provided has been beneficial. We certainly look forward to continuing our partnership with not only the U.S. industry, but the Western Hemisphere industry as well. So thank you so much for joining.
Thank you, Dr. Walker. Muchas gracias. Estamos muy agradecidos por sus aportes en este simposio. Ahora una pregunta.
We're very grateful for your contributions in this symposium. I'm going to read. In your experience, there has been a theoretical ideal variant, the unicorn rice, that can be used as the objective to pursue in the coming years. Considering market requirements, length, chalk, amylose transparency, and gel temp, and for the producer, yield per acre, sowing cost, harvest cost, water requirements, and plague resistance. And what degree of progress have we made in the direction of this ideal variety?
Well, I will do my best to answer that. I think you can tell from the length of the question that we are working with quite an extensive list of boxes to check, so to speak. And then I'll go ahead to say that in any given year, depending on what Mother Nature chooses to do at certain times during the season, even creates, I guess, more challenges for breeders as well as farmers. And I'll also throw in this, is that we do this with standard breeding practices, whereas we're not using GMOs and that sort of thing. But all in all, a perfect variety. I don't know that we'll ever achieve a perfect variety. I do think that things will continue to change. I also would caution anyone in judging a variety, in 1 year. Randy mentioned earlier, the worst thing that can happen for a breeder and or a seed company is to launch a variety and Mother Nature, throw a curveball, so to speak, in year 1, because many times that variety never recovers. If it has a couple of years under its belt of good performance, it can sustain, a down year for various reasons. But year 1 is very critical. So to answer your question, I do think that we have to look over time. I do think that improvements are very difficult at times to measure from 1 year to the next. But as we look over a period of, say, 5 years or 10 years, we I think can see trend lines that are, continue to go up for southern U.S. rice. I mean, we continue to raise yields. Just a few years ago, I know in my company, we didn't offer any blast tolerant rice varieties. Now, I think we only have 1 or 2 that aren't blast tolerant. So, from a yield stability standpoint, again, it's not what the variety can do, it's what it doesn't do when it does create, or when it does encounter difficult years, whether it's disease or weather or a combination of all of those things. So, I think we're all trying to provide sort of the floor in these varieties, and I'll go so far to say as even hybrids. If we can raise the floor of those so that they're more stable, I think we look back and say that that's huge gain. So, and I do think that we have done that. Some of the worst yields that I've heard this year in a very difficult growing season are still a far cry from where we were, say, in 2010 and in 2011. So, again, I think that we continue to make progress. We continue to try to bring all these traits together, and progress is it's often slow, but I do think that we are making progress, and I do think with the technologies and the tools that are available and the people that are committed to doing what they do every day, I think we'll continue to see progress for a long period of time.
Excellent. Another question that we have for you is, can you elaborate a little bit more on the varieties, say, CLL 15, 16, and 17? Do they look alike to CL 153 or CL 163?
Yeah, so, unfortunately, I'm not sitting here looking at all the data that was presented earlier today, but so I will try to shoot from the hip a little bit. So CLL, both CLL 15 and CLL 16, I think from a grain length standpoint, are very similar to the CL 111 and 153. So CLL 111 is around a 6.8 millimeter grain length. CL 153 is around a 7 millimeter grain length. And so our CLL 16 is going to be somewhere around a 6.9. I think our CLL 15 is about a 6.8. So our grain length is very similar. I think our chalk content in the CLL 16 is going to be overall very, very low, probably closer to approaching that of CL 153 Our CLL15 may be just a little bit chalkier, but we're not talking about the extreme of, the chalk that is very apparent in CL151 and some of the other very high yielding hybrids and varieties that are out there in the market today. So, so these varieties, I think, do a great job of showing the progress, to tag on to our last question a little bit, where our yields are equal to or greater than, for example, comparing within our own company, the CL151, but having a much better grain appearance. The amylose content, when they're intermediate amylose, intermediate gel temp, if they're truly a southern U.S. long grain, that amylose content is going to be within a couple of percentage points of each other, and that CLL15 as well as CLL16 are both southern U.S. long grain. So they're going to be in the range of 20 to 22% amylose with an intermediate gel temp. All of these varieties do have blast tolerance, so that that's not as much of a concern as it used to be with these varieties. And and from a package standpoint, I do think that they are, nearing the top of what's available today from a varietal standpoint in a good package quality rice.
Great. Muchas gracias, Dr. Walker.
Well, thank you very much, Dr. Walker. Next, our next panelist is Mr. Leandro Pasquale. Before we continue, we have one more survey. Survey number 4, please bring it up. The survey says,
changed in 2020? It's increased, it's decreased, or no change? Have your consumers' rice purchases changed in 2020? It's increased, it's decreased, or no change. Le doy un poquito de tiempo para analizar la
I'm
pregunta.
going to give you a bit of time to analyze the question and answer. In a few brief moments, we will see the results.
Bueno, 5. Bueno.
Very well. Rice purchases have increased.
Gracias por sus respuestas.
Well, thank you very much for your answers. Thank you very, very much. And now we welcome Mr. Leandro Pasquale. Mr. Pasquale is an agronomist. He has a master's degree in technology. Mr. Pasquale holds a master's in seed technology from the Santa Maria General University and another master's in business management from the Higher College of Propaganda and Marketing. He has been a member of RiceTec since 2004 when he began his professional career as an agronomist, a development agronomist. In 2009 and 2010, he was the rice business manager at Bayer AgroSciences, and in 2010, he became the new business manager at RiceTec. Welcome, Mr. Pasquale. Thank you for being with us. The floor is yours.
Are you able to see?
We're good. Thank you.
Bueno, antes de empezar, me gustaría solamente
Well, before we begin, I would simply like to say that it's an honor to be participating in this symposium, as well as to interact with key people and businesses in the rice development field in Latin America. It's an honor to be with you all. My objective today is basically to present RiceTec, tell you about who we are, what our mission and vision are, what our values are, how we work, and what are the products that we have here in the United States to offer producers and with our clients in the Americas. Very well, RiceTec is a technology company that develops seeds. We work with rice seeds, and our objective is to sustainably feed a growing world population. What do we offer? We offer goods and services that enable producers to achieve higher yields, making better use, more sustainable use of resources that every day are fewer and farther between.
Nosotros tenemos una aplicación de mucha investigación. O sea, nosotros
We invest a great deal in research and development because we understand that that is the key to our business. That's where we can discover traits or other technologies that can make a difference for producers and to the rice industry more broadly. Our mission is to drive sustainability in food production through rice seed technology. That is our mission. We deliver this mission based on 3 pillars that we express as values. The first is we innovate. We try to do things differently to achieve different results. The second value that we use to deliver our mission is the way in which we work. We work together to deliver exceptional results and the various needs as we find them. Third, we work carefully. We care and we try to respect people and nature, as well as incorporating safety and diversity in our operation. That's how we work to deliver our mission. RiceTec is based globally on 3 business units. This is where I am based in the United States. That's where our headquarters are. That was the first unit that was created. We have a second unit in Mercosur in South America, and we have a third business unit in India. These 3 different business units run research, seed production, and commercial teams in each of these regions. And the way we see it is that every time we face a challenge, we have to look at things a bit more holistically. We have to take a look at what lies around the world in order to answer to each question or come to a new result. So given that we run 3 different business units spread across the world, we can maximize information generated and bring this information to bear on the realities of each region based on what we observe in different parts of the world. So how do we work? We work through extensive research and technology. We use the best techniques in plant breeding. We combine the best possible methods. We use marking technology, etc. All of this to enable greater speeds in developing new products. Another important part is testing. We do a great deal of testing before coming to market. So before arriving at a commercial product, we've had more than 1,000 products, or we test more than 1,000 products in a given year before we make it to a commercial product. And this can take 5, 6, or 7 years to bring a new product to market. It's a major investment of time, money, and especially of knowledge to arrive at a commercially viable product. We also have an initiative, which is to work more and more sustainably all the time. Sustainability is in our DNA. We want our products to have more productivity, which means that we can generate more grain in the same plot of land. This varies between 50 and 20%. Our products also use nitrogen more efficiently. In addition, we produce fewer greenhouse gases, and our products can be grown with less water, and we all know that water is more and more restricted as the days go by. We also have products with various traits or characteristics. For instance, using the need to use fewer pesticides or fungicides, which gives us a more sustainable product as well. We have an initiative at RiceTec that is called Smart Rice, which is our initiative that brings all this together to produce more sustainability in our product portfolio. Smart Rice is about sustainability. Now, getting into the products, what do we have and what are we working on at RiceTec when it comes to new products? Much like the others who presented today, we work in the United States within 3 major market segments or technology groups. The conventional segment, where there's no use of herbicide. The full page segment, from the imidazoline family, and the segment of the market that uses herbicides, where we work with Max Ace. We are going to have new products within each of these segments. And I will now get into further detail for each of these products within each segment. So we're going to discuss 2 new products in the conventional segment, 1 for full page and 1 for Max Ace. And these products will be available beginning with the next campaign.
Convencional es el RT7801. Todos los productos que yo voy a presentar a partir de ahora son largos, grano largo. En nuestra codificación, el 7 es el número que define el grano.
The first product that we're going to have is the RT7801. So 7 shows long grain, 8 is the phyto, 0 is technology, and 1 is the launching number. So the product RT7801, a conventional product. So the length of the grain is about 7.3 millimeters with 2.3 length to width relationship of 3.1. So physically it's very interesting. As well as the chalk, it has low chalk. As far as milling performance, we're talking about a performance of 68% in total and 57% in whole. from the chemical point of view, it has a high amylose, 26%, and a gel temp low, that is low. So this is a product that has a high amylose and a low gel temp, a product that has a lot of acceptance in the meals that do parboiled rice, and for those that require a product that has high amylose and low gel temp because of the way that the grains cook. So again, you can see in the picture, a little bit enlarged, how this product is. So it's a long grain, quite uniform, long grain, high amylose, low gel temp, and low chalk. So this product is being offered starting in the year 2021 in the conventional segment in regards to the herbicide technology use. The other product that we're going to offer starting next year within the conventional segment is the RT7401. This is a product that has a shorter cycle than the previous one, is the same, very good length and width as far as physical characteristics. The size of the grain is very interesting, chalk is very interesting, and as far as the milling performance is also very good. The main difference is that the type of grain is characteristic for the US. In other words, intermediate amylose and intermediate gel temp. So this is a typical US product as far as amylose and gel temp. And having this product in this portfolio adds a very good physical appearance and a very good grain size, kernel size. Those are some of the characteristics of this product. Again, long grain 7401, starting next year, intermediate amylose, intermediate gel temp, and low chalk. So these together with the 7301 are the products that RiceTec is going to bring to market next year. The other part of the market, which is the technology regarding herbicides, we have the full page technology, and we're going to have a new product, RT7421 full page. Is quite an interesting product as far as kernel size. It adds low chalk. It's a product that has a good milling performance, and it's a product that has US characteristics as far as amylose and gel temp. So here you can see in the pictures, you can see from a close-up, the uniformity of the grains, the transparency. It has a very good kernel, and after this is mill, it looks very, very nice. So within the full page technology, the next launch is going to be this, the 7421 full page, intermediate amylose, intermediate gel temp, and low chalk. Those are the three main points of this product within the full page portfolio. Another news is the product RTV7231MA. So this is the first product in the Maxis technology for the market. It has a quite interesting kernel size, low chalk. Out of the ones that I have presented today, is the ones that has the least chalk, and it has very good milling performance. As far as amylose and Gel Temp, it has slightly more amylose than the other ones that are the typical US rices. This one has 21, and it also has an intermediate Gel Temp. As you can see here in the two pictures, you can see the looks of this product as far as the kernel. So you can see that it has a very good appearance. The main points of the 7231 maxes is intermediate amylose, intermediate Gel Temp, and low chalk. Here, I'm bringing to you the 4 new products side by side. The focus of the seminar was grain quality. So I'm focusing on the quality. They all have a very good yield. Right here, you can see side by side, and you can see that we are talking about a size that is between 6.9 and 7.3. As far as width is between 2.2 and 2.3. Chalk is very low in all the cases. Very good milling performance. And we have typical US products that have between 20 and 21% of amylose and intermediate Gel Temp, as well as a different product, which is the 7801 with high amylose and low Gel Temp. Those are basically the 4 products that we're going to be offering in a commercial way starting in 2021. Here again, you can see close-up photos where you can see very well the grains of each of the products, and you can see what we are accomplishing as far as kernel size, the chalk, and the appearance of the different products. So again, 2 products that are going to be in the conventional segment, 7801 and 7401, knowing that the 7801 is the one that is a little bit different from the other ones because it has a high amylose and low Gel Temp. The other ones, 7401, 7421, and the 7231 are US quality, like intermediate amylose, intermediate Gel Temp, and low chalk. They all have a percentage of chalk that is quite low. We work a lot on that. And this is the first wave of products that are coming. And they have this low chalk. The way that we look at the market, and I believe that we all agree on that, is that we need to meet in the best way possible what the final consumer expects. And they demand quality depending on where they are. What they mean by quality changes depending on the location. They also ask for consistency, that the product will have a consistent appearance. There won't be great variation. And they also require that the products are GMO-free, that they have good cooking properties, appearance, etc. The way that we look at that is that we need to make sure that this happens. And how can we do that? We do that through a chain that works towards this end, towards the final consumer. So we have a product, and we need to make sure that this product is produced, industrialized, and marketed, and that it reaches the consumer in a consistent way. If we do not have the product that the consumer is asking for, then we need to do a research and bring them this product. So the 4 products that I produced today are basically looking at the final consumer, the way to better take care of their needs. That's how we look at it. That's how we make sure that the consumer is always receiving what they really need. Here is my contact information. Again, it's a big satisfaction to participate in this symposium with people that are very, very important and that they have a great knowledge of this market. So I just share with you what RiceTec is doing, what we're doing, and what are the products that we can offer to this market starting in 2021. Thank you very much. I'm available for any questions that you might want to ask. Thank you so much, Mr. Pasquale, for your talk. And if we have any questions, can you please explain a little bit more about the smart rice and how this affects sustainability? Well, we work with hybrids, and so we have a higher productivity by surface area. We have a greater efficiency in the use of nitrogen, and we have low greenhouse emission parameters. So we are focusing on this concept in order to have a product that is more sustainable, commercially more sustainable. We know that the market requests, and some companies are requesting more and more, and consumers are more and more aware to not just a good product, a good quality product, but also one that is friendly with the environment. And our goal at Rice, with the smart rice, we want to have a product that is very good for you, that has the quality that you're looking for, and the cooking qualities that you expect, but is also going to be good for the environment. It's going to be good for you, but then also good for the environment. That's the big goal of our Smart Rice initiative. Did I answer your question, Aisha? Yes, thank you very much. Another question that I have is,
how would you or the farmers that you work with define rice quality?
Okay. Básicamente ese es el último slide ese que yo presenté, ¿no? O sea,
well, that was basically in the last slide that I showed you. It depends on the final market. The market is going to ask for a certain quality. There are markets that require as quality, high amylose and low Gel Temp. The way to work with that market is to work backwards, to identify the market, and then from that, structure how the production so that you can reach them with a product that that market asks for, but in a segregated way, where we have a channel already established to take care of that market. It's not easy to do that because we work in a big area with different varieties, different products, etc. But that's the way that we can best meet the needs of the market. Let's see, there is a market that requests U.S. rice, traditional U.S. rice. That's where we have those products with intermediate amylose and intermediate Gel Temp that are going to work very well when you mix them with most of the rices in the market, and you can work in you can mix all these rices with no problem. But when we are working for more specific niche, then you need to have identity preservation for the products. Well, thank you very much, Mr. Leandro Pasquale, for your talk. And now we are getting to the last speaker of this symposium. And we're going to hear from Dr. Raúl Guerra, who is going to tell us about his research regarding rice quality for Latin America. Dr. Guerra was born and raised in Managua, Nicaragua. He did all his formal schooling in the U.S. At the University of Wisconsin, he did a master on plant improvement, and then he worked in Managua, in Nicaragua, at the only rice farm in the country. There he met with an international USA rice delegation who helped him decide to pursue a PhD in Louisiana University, focusing on breeding for rice, where he's currently studying. Mr. Guerra, we are really excited about hearing for your findings. You have the mic. Thank you so much, Aisha, and thank you for giving me my doctorate before I got it. Well, I'm going to talk about what is still my project, which is the cooking characterization of the US and Latin American rice. So I'm studying this as a student, and I'm going to talk about my rice life, so as not to make it so short. I started working as a rice breeder in Nicaragua for Agrícola Miramontes. At that time, that was the only rice breeding program that was registered. And part of that experience was to go to Colombia to get to know the flour system and its materials. And I believe that that was very important because a big part of the rice that we eat in South America comes from flour and for sure from RiceTec. But that has a lot to do with the perception of quality that we have. Right now, I am focusing on rice breeding, especially in the grain and cooking quality, focusing on the point of view of Latin America. So I'm characterizing the US germplasm in order to find the things that they have in common and things that are different with the Latin American varieties. We're going to use DNA markers to facilitate the process. I'm going to talk a little bit about that. As we have heard today, during the day, the concern about the US rice has been chalk and the effects when it's cooked, as well as its length. The rice from the southern US has an intermediate amylose, an intermediate Gel Temp. But at a certain time, we had a cocodrie variety that had 60% of the planted area in Louisiana, and it was replaced by Chenier. So this cocodrie is a quality that is more similar to the Latin American rices, while the Cheniers is the classical rice with intermediate amylose and Gel Temp. So this change from cocodrie to Chenier and also to the hybrids marked a big, a noticeable difference with the rices that we cook in Latin America. So that's the focus in improving the quality for the Latin American market, which is something new. And it has brought to light that the different quality components are not just the amylose and the Gel Temp, but then also the challenge of having characteristics that are quantifiable regarding the cooking quality. It's not just to say that that is not sticky from 1 to 10. What we're trying to do is quantifying the cooking quality.
Una herramienta que estamos utilizando es este Rapid Visco Analyzer.
One tool we are using is this Rapid Visco Analyzer, which measures the viscosity of the flour, the rice flour, when it's mixed with water as the temperature drops. So it quantifies the results as the test is performed and has been acknowledged by the American Association of Cereal Chemistry, it can measure viscosity and gel temp.
Cómo leer
So I'm going
esta
to explain very quickly how to read this RVA graph, given that in several of today's presentations, this has been discussed. The good thing about this graph is the repeatability. It can be used in various countries, the methods are acknowledged, and there are several pieces of equipment that can produce it. Today, the RVA that we are using, the units of measurement are centipascals. So if you see differences between my results and those of others, it's simply a matter of multiplying by 10. The relative results are the same. So what the equipment does is raise the temperature and then drop it. It raises it, maintains it, and then drops it. And in that time, it measures viscosity, how viscosity rises and changes over time as temperature is controlled on its way up and down. The most important thing that we measure is this interval, the breakdown, the setback, and the final viscosity. The breakdown, many have related it to trough viscosity, which is basically the rate at which amylose is decomposed with temperature. If it decomposes a great deal, it causes more viscosity. The setback changes the texture as the temperature drops, and it's related to retrogradation. And the final viscosity, which is also related to consistency, has to do with the texture once the temperature drops. These are the three things that we're looking at with this equipment. So we've discussed a great many topics today, but with this equipment, what we're looking to do is create a quality profile. We already know that we want to focus on a long grain, low chalk, non-sticky rice with a texture that doesn't change too much after cooking. So with this equipment, the rapid visco analyzer, the seed count, which is a digital way of measuring the visual characteristics such as chalk, whiteness, length, and width. And we're also going to use DNA markers to facilitate selection. And with that, we will have clear, quantifiable objectives that will ease and accelerate the development of varieties for Latin America. The use of this RVA will soon become routine in the breeding process. But they won't be used as they have typically been used, which is using them only at the end to characterize a variety that is already finished. So the experiment that we're running at present involves taking 106 varieties and lines with long grain, although we've also evaluated short and medium grains and aromatic varieties, but the ones I will be discussing today are long grain. The varieties are modern as well as experimental lines. Programs from California, Mississippi, Texas, Louisiana, and Arkansas. The Latin American varieties we will be analyzing are 22 commercially available varieties from Central and South America. These are varieties that are used at present but aren't necessarily all that modern, that have been used over the last 10 years, say. And we also use RVA, seed count, and DNA markers to characterize these. Here are some of the results to give you an idea, a visual idea of what has been discussed today. Generally speaking, This peak viscosity, let me remind you that it's only for long grain varieties. So this peak viscosity, we can see that it's quite whitened. Here we have Latin America in red and the United States in blue. So the averages are very similar. So we won't worry too much about it, although it does have to do with biochemical characteristics that don't interest us at present. We see that there are major differences when it comes to the breakdown. In Latin America, the average breakdown is considerably lower than in the United States, which would indicate that there are important differences in the stickiness when it comes to cooking rice. However, there are some varieties that have an overlap in breakdown. We have some Latin American varieties with a very high breakdown and some American varieties with a very low breakdown. So these would be the varieties with potential to be crossed that we may focus on. The same goes for the setback. We can see that Latin America has, on average, a much higher setback, whereas the United States varieties have a much lower average setback, whereby some of you may have noticed that rice can get quite hard when it's chilled. We also see a notable difference in consistency between Latin America and US varieties, higher consistency in Latin America, and a lower consistency in the US. The Gel Temp, which has been much discussed, that Latin America has a low Gel Temp and the United States has an intermediate or high Gel Temp, we can see that there are some varieties from Central America that also have very high Gel Temp. One example is PAL02, developed in Venezuela, very popular in Central America, that cooks very well, but a high Gel Temp. So these are some of the points that we will be observing in order to determine what is the limit of gelatinization temperatures for the variety to be acceptable in this market. We can see too that when it comes to final viscosity, varieties in the United States are concentrated in a low portion of the chart and low, whereas Latin American varieties have a wider distribution when it comes to final viscosity, but an ultimate concentration that is higher than the US. So when we bring all of these characteristics together, we see clear goals through which we are searching. It may not be an exact point, 642 say, but we do see a high degree of flexibility for selecting certain varieties that are produced in the United States but may still be acceptable in Central and South America. This is a case in which we used seed count to measure grain length. And we can see that Latin America, generally speaking, has a slightly larger grain. But there are many varieties in the United States from which to select that could satisfy the Latin American market. Now, as we have seen for chalk, the difference is quite notable. The chalk in Latin America is very low compared to the United States. In this case, I'm using the chalk surface percentage, chalk area. Here's an example of IRGA 424 with a chalk area of 3.8%, and you can see that there are few grains with a high chalk area. What seed count does is take an average of the surface of all of these grains. So as we can see, the average of 2.96 is for Latin America, whereas the US is almost 14%. These two varieties from Latin America are two old varieties, one from Uruguay and another from a Brazilian program. And I do not believe them to be representative of Latin America overall. The length-width ratio, which is quite important, we can see that Latin America has a higher ratio than the US, but there's still a very large overlap from which we can select. So the good thing about using this equipment is that they can provide us with clear goals. They can tell us where we're at when it comes to comparing the two regions. Another tool that we're using, and I won't get too far into the weeds here, because it might require an entire additional presentation, but if any of you are interested, you're welcome to contact me, especially because we want to collaborate with people in Latin America and anywhere in the world. So the use of genetic markers can help us to select ahead of time, that is, without waiting for generations to be too far advanced and at a much lower cost than using any of the equipment already mentioned. In this case, a combination of markers gives us very specific classes by varieties that have setbacks that fall into different categories. So these four combinations of markers can allow us to say, if we want a setback between 1,500 and 2,000, we'll use this set of markers and we'll select the varieties with these markers. So this facilitates selection without having to run the RVA equipment. Same goes for the breakdown. We can see that there are clear differences among these four groups of markers. When it comes to final viscosity, there is one combination of markers that gives us a clear difference when it comes to a high final viscosity. So again, if you're interested, I can explain this in further detail in the Q&A. I've reserved quite a bit of time for your questions, so we can get into it then. Current and future efforts that we are undertaking in Louisiana at the Crowley Experimental Center, we discussed the 7 advanced lines with high amylose and potential for release within a year. These have all the acceptable characteristics that we've spent all day discussing, in particular, high yield, and also crosses that we've made in 2018 for high amylose and low gel temp that we are evaluating currently with the RVA. This population will allow us to continue improving our method as I described it. These will be planted on multiple locations to ensure that they are broadly acceptable here in the United States among producers and in Latin America. Last year and this year, we have been running crosses with germplasm from Latin America and the US in order to obtain new possibilities for the future. In this case, to ensure that we will have varieties with certain characteristics so that they can be introduced in the germplasm of the US. One very important thing that I wanted to mention is that we would like to collaborate by sending those of you who are interested provisional samples for you to cook it and run various tests. Likewise, Should you like to send varieties of your own that are already milled, you may send them our way, and we will run tests in order to continue with these comparisons of US and Latin American varieties, especially with the modernization or new varieties that are emerging from Latin America. With RiceTec and Horizon, we know that their acceptance will vary as well. So it would help us a great deal to analyze whatever samples you are working with. I've left a lot of space for questions since I imagine that what we're doing with the RVA could be interesting to you. So I've left space to hear what you have to say. And thank you very much, in particular to the organizer of this event, USA Rice, for your coordination. Thank you very much. Thank you very much, Mr. Guerra, and congratulations on your doctorate. The study you're doing is impressive. And we hope to see much more from you in the future. And now we have space for questions, Q&A. One question for you, Mr. Guerra.
Is caused more by genetics or climate?
¿En español o en inglés?
En español está bien.
Ok. Bueno, hay genes grandes o digamos.
Well, there are big genes or genes with a big effect that control chalk. However, as Dr. Linscomb told us this morning, there are environmental effects that affect the amount of chalk. So we might say that genes can place us in one category or another, or place us, say, within 10 and 50%, within 5 and 10%. They're not exact numbers, but it's an example. Genetics can place us in certain classes of chalk, and then it's climate or environment that actually operates within those ranges, especially high temperatures, differences as the grain is filled, which can cause a non-ideal filling of the grain, which we know is chalk. So I'd say that both are involved. There are certain genes that have a big effect and other genes that have a lesser effect. Thank you very much. I'm going to pause briefly to invite you all, to invite all the panelists to please join us in this next session of Q&A. To make sure that you're all with us and available, I'm going to give you a moment to open up your cameras so that we can continue with the Q&A session. All the doctors, all the speakers at the symposium, please, if you're still with us, open your cameras so that you can join us for the panel's Q&A. And thank you very much. Very well. Congratulations. We have more or less concluded this seminar. Continuing with the final Q&A. I believe this question goes to Dr. Walker. That's right, Dr. Walker.
Can you briefly explain the difference between CL and PV systems from a farmer's point of view? Si alguien puede responder, yo creo que eso era para el Dr. Tim Walker durante su presentación.
I believe that was for Dr. Tim Walker, during his presentation.
Dr. Walker?
Okay.
Dr. Walker?
So Aisha, just to be sure, the question is to explain the difference between Clearfield and Previsia. Is that correct?
Yes, that is correct.
Okay. So I would say that the Clearfield and Previsia are trade names for two herbicide tolerant systems. The Clearfield technology has been out, for almost 20 years now, or maybe it has been for 20 years. But the Clearfield system is based on the imidazolinone tolerance, rise tolerance to the imidazolinone family of herbicides. So the herbicides, New Path and beyond, are those imidazolinone herbicides that can be applied over the top of these rice varieties without, killing the rice varieties. Those herbicides act both from a systemic standpoint as well as a residual. So we've had very good success for a number of years controlling red rice with this system. The Previsia system is also an over-the-top herbicide system, but it is not of, it's a different chemistry, it's a different trait in the variety. So Previsia rice is tolerant to the Previsia herbicide. The Previsia herbicide, the active ingredient in it is called quizalofop, and it is what we call an ACCase tolerant system. So it's a different mode of action. And right now, the issue that has developed over the course of time is we have ALS resistant weedy rice, whether it's red rice, whether it's volunteers, but we, I guess, have coined the phrase the weedy rice complex. But the Previsia rice system is now the only over-the-top herbicide that will kill the ALS resistant weedy rice without injuring the domestic crop or the Previsia variety.
So, Aisha, this is Steve. If I might add,
of course,
we often get the question, how is this technology developed? Is this a GMO? It is not. As was stated several times today, we have no GMO technology in commercial rice production in the United States. Both of these technologies were developed as a result of mutation breeding, which is a very old technology for creating new traits in rice as well as other crops.
Muchas gracias, Dr. Steve Linscomb. Otra pregunta que tenemos es...
Thank you, Dr. Steve Linscomb. We have another question. The soil in Latin America and in certain regions, in certain areas, is much richer in some nutrients. Do you consider that this factor could have an influence when developing these new varieties low in chalk?
So, Aisha, I'll take a stab at that, and hopefully somebody will correct any errors, but we have not seen a real direct correlation. We have some of our rice soils in the United States are fairly poor soils, but some of them are much what I would say better soils, richer in nutrients. And we have not seen a correlation relative to chalk dependent on soil type. It typically, as was stated a few times, and Raul stated just recently, it's, we have some varieties they're very seldom are chalky. And Cypress was a very good example of that. We have other varieties that are always chalky. Some of the original Green Revolution varieties that came out of International Rice Research Institute, IR8, which kind of revolutionized rice production in the world, is always chalky. And some people actually prefer that particular characteristic in the grain. Most of our varieties are kind of middle of the road. If we have ideal growing conditions where we don't have a lot of high daytime and nighttime temperatures during the grain fill period, we might not have much chalk. But if we have those conditions, if we have high temperatures, the chalk level is going to be much higher. But we have not seen soil type to be a major factor.
Muchas gracias, Dr. Linscomb. Si alguien más tiene...
Thank you, Dr. Linscomb. Does anybody else have a point that you would like to make? Please go ahead. Otherwise, we can go on to the next question.
Is the U.S. specializing southern states producers to serve Latin American markets? Or will these varieties be available also in Delta producer states? That's a question in general for our speakers.
Aisha, could you repeat it?
Of course. Absolutely. In the U.S., is the U.S. specializing, the southern states specializing to serve Latin American markets? Or will varieties also be available in Delta producing states? So,
well, I think the whole gist of the symposium today kind of reinforces that the breeders, especially in the southern United States, and as well probably as Dr. McKenzie showed in California, are very focused on developing new varieties. We consider Latin America one of our best markets, and we, or the breeders, want to develop varieties that fit very well with the preferences on all of the characteristics that have been discussed here today. So yes, it's a major focus. And these varieties in the southern United States, we've got some variation in the performance of varieties across the various regions. But in general, if a variety does pretty good in the southern part of our rice growing region, Texas and South Louisiana, it's probably going to do fairly well throughout the entire region on up into Missouri and even southern Illinois.
thank you, Dr. Linscomb. Another question that we have is, will your high amylose varieties need identity preservation? And a second part to that question is, I'll read the whole question. Will your high amylose varieties need identity preservation? And, oh, I just lost it.
I'll comment on that as well.
Okay, go ahead.
Asia, certainly I think for the most part they will, because the cooking characteristics, as Raul did a great job of explaining, is very different between what I like to call the indica types, the high amylose, low gel temp, and our traditional southern U.S. long grains, which have high intermediate amylose and intermediate gel temp. So if you mix those two types of grain together, they will cook fairly ununiformly. So I think that IP is going to be very important as we come out, as the breeders come out with some of these higher amylose varieties that are, if it's a high amylose, such as Rexmont, those can be co-mingled with our typical southern long grains, which have, because both of those have intermediate gel temp. But if you've got a high amylose and a low gel temp, probably going to need to be IP from the traditional southern cereal chemistry long grains.
Thank you. Another question that we have coming in. How challenging would it be to load a vessel of 15, 20, or 300,000 metric tons with paddy of the same variety?
I'll comment.
Go ahead, Tim.
Okay. I don't think the challenge is as long as it's organized earlier in the process. That challenge becomes really no challenge at all, I would say. The problem that we've run into in recent years with IP is that the crop is already in the bin, and then, you know, a merchant comes along and wants to source, you know, an individual variety. That becomes, you know, I mean, sometimes it's an easy challenge, sometimes it's very, very difficult. But an almost surefire way for it to not be really a challenge at all is to come in prior to planting decisions being made, you know, and having that some type of a contract available. No different than what we would do with maybe, you know, the aromatic types or the even medium grains. So.
Okay. Thank you, Dr. Walker. Bueno, otra pregunta que tenemos es...
Well, another question that we have is, in general, the trend as far as the price of rice right now is to go down. What could be the trend of the price for the rest of the year and for next year?
So you're talking about the U.S. market specifically, or?
I believe, creo que sí.
Yes. Yes, the U.S. market.
Yeah, you know, we have some emerging markets. Brazil has come into play because of their water shortages down there. So there is a possibility if they would jump in. We have already made some shipments to Brazil in that region. There's a possibility that could have a positive impact on the U.S. market and U.S. prices, but I don't think there's a huge expectation that we're going to see any major change in price of U.S. rice going forward on the short term.
Muchas gracias. Otra pregunta que tengo ahorita es...
Another question that I have right now.
Global population increases each year, and food scarcity is a problem in many countries. Additionally, over 800 million people are undernourished. When you're developing new varieties, do you look at augmenting the nutritional composition of rice to help you with world hunger? Muy buena pregunta.
Very good question.
So Aisha, I don't want to answer all the questions, but I will make a comment that Dr. Ida Winfrieder that works with Adam at the Rice Station in Crowley a few years ago developed through mutation breeding, as well as I was talking about earlier, a higher protein rice line that is being grown on a limited basis. Actually, it's being grown right now in southern Illinois and South Louisiana. So this is an example of an improvement in rice to address issues in areas where people might not have sufficient protein available in their diet.
Yeah, this is Adam. I'll just add to the comment on this question. It's something we get regularly, but I would say as breeders, we're typically tasked with developing varieties and traits that serve our market. So if our market or our stakeholders demand certain characteristics, that's what we're typically going to focus on. So in the case of in the U.S., it's mainly the types of traits we spoke about today, and mainly that's what our markets are demanding. I think a lot of the quality aspects are with rice, or more with the fortification and things like that, which are after production in the field.
Muchas gracias por ese aporte. Otra pregunta que tenemos es,
thank you so much for your contribution.
In the United States in the year 2040. Y esa es una pregunta para todos los panelistas.
That's a question for all the speakers.
Aisha, repeat it, please.
Of course. What do you think rice production will look like in the United States in the year 2040? So 20 years from now.
Yeah, I'm going to let some of these younger breeders address that. But one way I would answer that question is, if we go back 20 years ago in my career, things have changed dramatically. During that period of time, we've seen the introduction of Clearfield rice. We've seen the introduction of Provisia, which is not only allowed for the effective control of weedy rice, but in some areas it's actually allowed for the changes in the way that rice is planted and flooded, which has had very positive environmental impacts, helped increase yields. We've seen over that same period of time a significant increase in yield from both the introduction and the successful introduction and utilization of hybrids, as well as increasing yields in the pure lines. So I think if we look 20 years down the road, one thing I think that is going to become much more important is looking at some of the sustainability factors, which may cause the industry to kind of reevaluate the way we grow rice. If rice production can be done such that the crop produces less greenhouse gases, I think that's going to be a significant improvement. And we do know that we've got some different things that we can do that might impact all the various sustainability metrics. But I'll let some of these younger gentlemen here maybe address that as well.
Por favor, sí. La palabra es de ustedes. Siguen adelante.
Please go ahead. The floor is yours.
Steve, I would like to add maybe a little bit outside of the box, but I think just having lived in rural America all of my life, I do think that farm labor is something that will continue to gain a lot more attention. So you either have to restructure some things socially or I think you'll see a lot of more, automation, whether it's, I can't even think of it, but I guess driverless equipment and all of that. So I definitely, in the grand scheme of things, without going into a lot of details, I do think that just the rural economy and, farm labor and all of that will be something that we deal with much more significantly in the next 20 years.
Just to expand a little bit on that, so what we are saying right now on row rice, right? So one of the main reasons of why row rice is growing is pretty much because of the labor, right? And of course, the grower is saving water. The grower is going from rice to soybean or to another crop very easy, right? So this is something that's changing, and we are living this right now. And if we look to the Asia, for example, what's going on in Asia right now, again, labor, as you mentioned, Tim, is a big thing over there as well, water scarcity. So they are going to rows. So they are using dry seed, they are using drills. So the HT is gonna be a big thing in Asia in the next years. So just to give an idea how the things are changing, right? And I agree with Linscomb. So the way that we grow rice will be different. That's for sure.
So just to follow up, it's kind of interesting for me. I've been traveling to China for almost my entire career, about 40 years. And when I first went to China, everything was done by hand. Everything was transplanted. Everything was harvested by hand. Everything was threshed by beating rice on a piece of plastic. And I have, in my career, seen that change very dramatically because of labor. You would think that a country such as China, labor would not be an issue. But the way it's explained to me, all of the young people want to go to a city and work in an air-conditioned factory instead of transplanting rice and harvesting rice by hand. So that, I think what everybody has said here is going to be very, very important for us. Like Tim said, automation, increase the use of drones for scouting and all of the other things that, we've been promised we will be able to do with drones. So all good points.
Excelente, muchas gracias por sus respuestas. Tenemos otras preguntas más.
Excellent, and thank you very much for your answers. We have some other questions, but there's another comment. Please go ahead.
Yes, Aisha, can I add something to it?
Absolutely.
Yeah, I'm not planning to work another 20 years, so even though I'm a little bit younger than that, still is coming. But my guess probably going to be more diversified. Probably not like commodity based, maybe have some contract based niche market. Just like California, I got 9. Kent, you mentioned I got 7 different class of marketing group or something. So maybe more aromatics, more nutraceutics, black corner rice, all those kind of things maybe. That's my thought.
Excelente, muchas gracias, doctor. Otra pregunta que tenemos.
Thank you very much, doctor. One other question we have.
From the United States, which of these varieties offers a better performance for parboiled rice?
Aisha, the question was a little bit muted, but I think you said which varieties work the best for parboiled rice?
Exactly. Of all varieties in the United States, which offers better performance for parboiled rice?
I will let Dr. Linscomb correct me because I'm probably a little bit out of my line. But in the work that I did, it was a lot of the rice that worked the best in parboil in the United States gave us the best opportunity for acceptance in Latin America, and vice versa. So that's my experience. Which factors I would have to yield the floor to Dr. Linscomb, Mr. Raul, and those guys, but nonetheless, that was in my limited experience.
Muchas gracias.
No, and Tim, that's you're right. You can parboil a lot of different types of rice. Parboiling will correct a lot of mistakes. If you got a very poor milling, a lot of rice, the parboiling process helps dramatically and increases the milling yield. And the answer I would give to that is that, in my experience, it depends on which mill you're talking to. Some mills only want to parboil the Rexmont CO163 types. Others will come back and let us know when they look at samples. We think this is going to be a very good parboiling variety just by looking at a sample of milled rice. So I think the answer maybe depends as much on which parboiling facility you're working with on a parboil product.
Thank you, Steve. Una pregunta más. Is there a
One
limit
final question.
to the yield of rice? And at what stage will it require complete change in plant architecture to achieve gain? I'll repeat that one more time. Is there a limit to the yield of rice? And at what stage will it require a complete change in plant architecture to achieve gain?
I'll go ahead, Adam.
Take a stab first. I guess theoretically, I don't think there is ever a ceiling. When you look at crops like corn or soybean in the U.S., people have been talking for many years, what's the cap? And when you look at, there might not be profitable production practices, but when they have these yield contests, there's people every year, 600 bushels of corn, when not that many decades ago, people couldn't think you could do 200 bushels. So I don't think there's ever a ceiling. As far as changing the architecture, I think if anyone was ever, practically speaking, it's kind of a challenge because you would have to go down into some sort of valley to get back to the next peak. So I think for someone to come in and say, we're going to restructure the entire plant, you would have to have a lot of resources and very patient funding source, because that would be a very long-term endeavor to completely restructure the plant. And I think examples of where people have tried to do this haven't really panned out to be too successful. So I guess in theory, there might be better plant types and things, but to put that into practice commercially, I personally think is a bit of a challenge, maybe not realistic.
So to follow up on that, Adam, there is a big project at the International Rice Research Institute to convert rice from a C3 to a C4 type plant. And, I've kind of followed that through the years, and hopefully they're successful, but up to now, it's been at best a challenge. Which, and basically, if you were successful there, that would probably allow a pretty significant yield increase with the same resources in growing the crop.
I guess I'll weigh in as one of the older people here. I know I'm older than Steve. So,
Doctor McKenzie, no podemos escucharte muy bien.
Dr. McKenzie, we can't hear you quite well
Sorry, I
enough.
was listening in translation.
Habla súper fuerte y después
I'm
sí.
afraid it hasn't improved. Speak very loudly and we'll be all right.
So in my experience over the years, in our programs, at least in California and South, we have some very different plant types that produce very high yields. A lot of factors involved in that. The problem with changing major plant types, like Adam has addressed, is we're here having a meeting all about quality. And I can tell you it's been very, very difficult to bring an exotic germplasm into our medium grains and maintain the quality. So I think that's going to be a challenge for the future, is making those next jumps, because everybody's raised their yields quite high, frankly, in the US, and each increment gets harder. The other thing I think we're going to have to face is hopefully LSU and Arkansas and Texas will continue to train plant breeders. We're going to need people to do that. They got to go out in the field, and that's my hope for the future. And everybody's going to have to face more regulation. So, thank you.
Bueno, muchas gracias a todos los ponentes de este
Well,
simposio.
thank you so much to all our speakers at this symposium on rice quality. If you have more questions, please email them to me. But our time today is running out, and I want to give you some final bits of information to finalize this rice symposium. Once again, thank you to our speakers. Thank you for your research and your statements today. They have been wonderful. And we have one final survey question for today. The survey question number 5. Here it goes.
Do your consumers prefer U.S. origin rice over other imported origins? Yes or no? Do your consumers prefer U.S. origin rice over other imported origins? Yes or no? Les doy un poquito de tiempo para analizar bien y darme la
I'll
respuesta.
give you a bit of time to analyze the question and give me your most heartfelt answer to this question. And here are the results. There's a slight favoring of the yes response. So thank you for your answers. Thank you very much. And some final comments to close. First of all, thank you all for being with me and with us, USA Rice, on the US Symposium on Rice Quality. I'll inform you that all participants will have access to the resources used during this symposium on the USA Rice website. There you will find all the presentations that we have projected, as well as a form for requesting rice samples, as well as meetings with the speakers and suppliers. In addition, you will be able to request collaboration with USA Rice on promoting your US rice brands. One final important thing, which is that after 2 days, you will receive a survey asking your opinion on this symposium. Please be sure to fill it in and send it over. I invite you as well to contact me directly at my email, agrigsby@usarice.com, for any comments or questions. Finally, I invite you to look us up on social networks